content, sir.
It's in the supplement.
Okay.
In the portal itself, you'll see a folder. After week 1, you'll see a folder that is supplementary. There you can find the book. Okay. Okay. So what do you have in the last session? What did happen in the last session? Last session you were there or not?
No, just doubts of regarding what means here, those activity questions and all doubts regarding maths. Week 1 doubts.
Okay.
Sir, can we get PYQ of mock 1?
You'll get it after before this quiz. I guess.
Quiz, yes.
1 week before the quiz.
Because
if you want to get it earlier, you can just find it if you know. Okay, so you're not able to know any people, right? If you know any other guy who is already there in the diploma and all, so you can ask him. But on the portal it will go 1 week before the quiz or 2 weeks before the quiz. So you'll get for 1-2 weeks at a time, and then you'll get for 3 and 4. Okay.
Actually, sir, I cleared May term and then I choose stats and English. And at this end term, I cleared both that subject. And now I choose maths, CET and English too. So when I give my first quiz 1, that time I cleared my maths and I studied 4 weeks that time, and now it's showing from first week. So can I give another quiz 1? Because last time I give quiz 1 and that was cleared by me.
So you cleared right last time. You did maths 1 whole, or you didn't? You just drop it from there itself.
No, I didn't choose maths that time.
So did you complete the maths 1 last term when you qualified?
No, I choose only stats and English. Not
okay,
complete.
then you have to do it this time. Yeah, you have to just sit in all the quiz. You have to perform well in every quiz. You already qualified, that is fine, but you have to write all the quizzes. Okay, for this
and
term.
my last quiz marks is.
You just wrote only 1 quiz, right?
Okay.
That was the qualifying one, correct?
Okay.
Yeah.
Excuse me, sir.
Yeah.
Excuse me, sir.
Sir, I have doubt in stats. Can I ask it here?
Stats, yeah, I can take that doubt, but this is not the session for stats. I can take the
No,
doubt,
sir,
but
I have just one doubt, sir.
okay. So maybe in the end we can take that, but it's because this is scheduled for math. Okay.
Hello, sir. I have a doubt in maths.
Okay. So yeah, so I'll start the session. If you don't have any other queries, I'll just start the session. So we'll just today our agenda will be, we'll just go through the sets and relation. Not sets. Sets is pretty simple. I don't find we'll be having any issue in that. We'll start the different type of relation, okay? And then we'll discuss all those things, and then we'll move to function. Okay.
Sir, I have a doubt with regards to sets only. Just one.
You have a doubt in what?
Sets. Activity 1.6, question number 5. I'm not able to understand the concept.
Okay.
Sir, I am a J-based entity. I cannot access to discourse forum, sir.
Discourse forum after you'll get the access.
When did I get access, sir?
You already qualified, huh?
Yes, sir. I am a J-based entry, sir.
Okay. That you need to ask the. You'll have the that you have to ask the portal team. I guess.
So invites only, sir.
Which invite? Did discourse invite you didn't got, or this
Discourse
link?
invite.
Okay.
Sir, what we are going to do today?
Yeah, so today we'll just discuss the concepts of week 1, and then if you have any
Sir,
doubt,
can we have the summary, please? We don't have it.
Excuse me, sir. I have a doubt in a question. Which was
first
given,
I'll do the summary, okay,
Yeah,
of week 1, and then we'll take the doubts. Okay. Is
Thank you,
this
sir.
fine?
Yes, sir. Yes.
Sir, will we be solving sums today?
Yeah, we'll discuss some problem after discussing the concept. I'll just go through the concept very briefly, and after that I'll go through the concept.
So can you please discuss relation and functions?
I'll start from there only. Okay, I'll just relation. I'll discuss all the four relation,
Okay.
identity. Okay, and then if you are having issue in those, I'll discuss because those are very important for your paper also. So you can expect a problem from there.
Yeah,
Okay.
so sets are easy, but we have a doubt in relation and function. So can you clear
Yeah, yeah. I'll
the
start with
relation function?
relation and functions only.
Yeah, yeah.
So I have some notes. I'll just open that. Maybe I'll just searching.
Sir, I have a one doubt.
Yeah, yeah. Go ahead.
Sir, decimal number is also a irrational number.
Erasure, not no. It's not erasure.
Sir, please start the session.
It is irrational number, sir.
Yeah. Okay, so let's start with the relation. Let's start with relation. Okay, I'll take the sets also. First, I'll discuss the relation. Okay, because most of the people generally find this relation bit difficult. Okay, so I'll start with relation, and then I'll discuss sets also. Wherever you have an issue, or maybe numbers, irrational, rational number, or any other points. Okay, is that fine?
Yeah, sure. Thank you.
Okay, so I'll just share my screen. If you can see my screen, just let me know. You're able to see my screen, right?
Yes, we can.
Yes, sir.
Yes, sir. Yes, sir.
We can.
Yes, sir. Yes, sir.
Yeah. So this is what I just written it for you. You can just I'll just share this file also. But this file is basically consists of all the week 1 to 4 content. Maybe a brief from week 1 to 4. Maybe that will help you in the
You can
question.
share it.
Sir, how can we access this file which was shown on your sharing screen?
Yeah, I'll share it after this session. Okay. After every session, whenever I will take it, I will share the slides that I will use. Okay.
Okay.
Okay. Okay. So can somebody tell me about the Cartesian product? Anybody has any idea about the Cartesian product? What is basically is?
Yes, sir.
Possible pair of two factor
So so it's basically a product, like we have to multiply from one element from set A and the other element from the set B.
Yeah. So A cross B can be your one Cartesian product, right? Where you are taking two values you are taking, one from the one set and the other from the other set. So basically here we are having two sets. What's the name of the two sets? A and B, correct?
Yes.
And this sets is a it's not like non-empty set. So the non-empty set means what? You have some values inside that set, right? It can be finite, it can be infinite. Okay. So if you have an infinite, so what do you mean by infinite and infinite? Can somebody tell me about that?
Like never ending. There are so many, like you can't infinite.
Correct. So if you have infinite sets, then that mean that you have a large chunk of number that you can't count. Like you can't think of that number. Okay. And the finite is like some fixed value, 5, 10, maybe 100,000, some random value. Okay. Can somebody give me an example of a set that is finite?
So
Sir, finite might be
of natural numbers which is less than 10.
number of prime numbers. Set of base of prime
Less than
numbers.
10.
Yes.
And what is
Set of prime number under 100.
correct? That is also correct. You can just count that number, right?
Yeah.
Okay. Or maybe set of player playing in this some particular match. Okay. Anything where you'll be having only 11 player that is playing that match.
Number of participants in this meeting.
Correct. Can you tell me about the infinite set?
Set of
Natural numbers.
Set of
Set
all
of real numbers.
prime numbers.
set of integers.
Set of integers. Set of rational numbers.
Set of all integers. Set of all real numbers.
Set of real numbers.
Okay, so if you have two sets, okay, and both are non-empty set, you can get a Cartesian product of that. Cartesian product basically means A cross B, where you are basically generating some you're generating a relation. Okay, please mute yourself, everybody else. So I can't check it now. Okay, so please mute yourself. Okay, whenever you are speaking or something, speak that at that time and then mute yourself again. But otherwise, it will be like okay. So I was just talking about the Cartesian product. So basically you have two sets and that both are non-empty set, and then you can get a cross A Cartesian product where you'll be getting a large number of, what do you call that, element of a set or a relation, where you'll be having in each of the relation, you'll be having A and B. Okay, and one set you'll be getting from one value, you'll be getting from the first set, and the other you're getting from the other set. Okay, it's like a pretty simple, it's not that difficult, you'll get. And if you have, okay, so if you have a Cartesian product, basically A cross B, like for example, I'm just giving you A equals to simple number A and B equals to 1 and 2. So how many values you'll be getting if I have to get the whole total Cartesian product? How many values you'll be getting in that A cross B? Set? Four element you'll be getting, right? What are the values? A1, B1, and then A2, B2, correct?
Yes, sir. Correct.
Yes, sir.
So is the order important in this?
Yes,
sir.
Yes,
sir.
the order is important.
Order are important. So A comma 1 is not equal to 1 comma A.
Because whenever you are writing A comma 1
Yeah.
and 1 comma A, both are different, right? But
Yes.
was the same case in the set when you were writing a set, like when, for example, a set of 11 players, or maybe 3 players, okay, or maybe vice captain and captain, okay?
No, sir, order is
No,
Was
not
sir.
the order relevant there?
Order is not important.
No,
Was the duplicate, you know, right? If
Yes,
you're
sir.
writing the same thing
Yes,
again
sir.
and again, was the
Duplicate
duplicate
does not
relevant in
matter.
the set whenever you were writing the set?
No,
sir.
it doesn't matter.
It matters in set.
Duplicate does not matter.
Yeah, it was not making any impact. If I'm just writing it, set A equals to A, and B, and this is a set. How many elements are there?
Though two elements.
Two elements.
Two elements.
Why not 3?
Because
Because A is a duplicate.
Yes, sir. And elements of set should be unique.
Because A is having a duplicate number, right? Like basically you have A and B only, right?
Yeah.
If the order doesn't matter, duplicate doesn't know. So the number is basically A and B. That's it. Correct?
Yes. Yes.
So there are basically some properties of the relation. Okay. So if you are having A cross B, okay, so you can have if you have two sets A and B, there can be a large chunk of relation, right?
Yeah.
Correct? If you have two boxes and you have to just mark a relation from A to B, you can have a large number of relations, correct? And that relation, whatever you'll be having, okay, that relation will be a subset of A cross B Cartesian product. Did you get the point? Whatever I told?
Yes.
Yes, yes.
Yes, sir. Yes, sir.
Whatever I told is correct, right? So if you are making any relation from A to B, if you have a two set and you have a Cartesian product A cross B, okay, so whatever the relation you are making, that will be a product Cartesian, like a subset of that, whatever the Cartesian product made. Okay, correct? Okay, smaller. Okay, so what do you mean by subset of any set? Any
A small group of that set.
correct? A small group from the bigger group. Correct?
So just a minute. So you mean to say that some sets becomes the relations of it? Sorry. Some sets becomes that Cartesian product.
No, you are making a Cartesian two sets. You are You are having a two sets. Okay, and you are just calculating the Cartesian product of that. But basically, you are generating something. Okay, you generate A cross B. You did it right. So in this A cross B, you'll be having all the relation that can occur between these two sets. Correct?
Yes.
Correct. And you're particularly finding out a particular relation. Okay, from A to B. So that relation, because this is a particular, like only one relation, right? And here in A cross B, you have all the relation. Correct?
Yes.
All the relation can have A from A to B. Okay. So A cross A to B. So one particular relation will be pakka subset of this A cross B, correct? Or the smaller group of that A cross B Cartesian product, correct? So this is what I am saying. Okay. So we have basically have 4 properties or 5 properties, you can say. The most important is the 3, but you can make it like larger also, anti-symmetric and then asymmetric and all. So many things. But basically you have about 3 sets. And what are those? Basically reflexive, transitive, and symmetric. Okay.
Symmetric.
Yes, sir.
Okay. So there is one more identity. I'll discuss that also. So in the reflexive relation, what happens? Just read the word word by word, okay, the line. So here, if you have a relation R, let R be a relation on set S. So there's a some set S, and then R is a particular relation that you are making on some set S. So there's only one set S. So what will the Cartesian product for if I'm making a Cartesian product of S? What will be that? S cross S, right?
Yeah.
Correct?
Yes, sir.
Yes,
Okay.
sir.
That you generally call it as binary and all.
16 element.
So what is that 16? Okay, for this S. No, I'm just telling that you have a set S and then you are making, you have a relation R in that set S. Okay. So so that R, whatever you are taking that R as a relation, that R is reflexive if and only if for all. So mark this word all. So only if for all X belongs to S, this is a set that we have taken, right? This is a set where we are making some relation. Correct? So this is the set where we are making some relation. So R is a reflexive if and only if for all X. So this should satisfy. So this condition should satisfy not for some X, for all the X belongs to S, XX should be present. Okay. XX means it can be any value that is present in S. So here if we have A, B, C, D. So can somebody tell me one value of X from this S set?
A, comma A.
A, right? So that can be
A,
X.
comma
If I'm taking Xi, it can be X1 basically. So that can be A, right? X2 I'm taking, that can be B.
B.
X3, C, and X4. Yeah. So this is what I told. R is a reflexive when only if for all the X, for all the elements that are belonging to this set S, the other value, the X, if I'm taking X1 as A, then A should be present. Then B, if
So
I'm
there
taking
is echo.
should be present. CC should be present. DD should be present. Okay, then only it can be a reflexive. Let's, for example, one example I'm asking you. If I have a relation R, and if this is something like this, AA, BB, is this a reflexive? Is this a reflexive?
No, it's not reflexive.
No, sir.
Why
pair
not? Because I
CC and
told you.
DD is missing.
All the elements
All
are
the
not
elements are
present.
not there.
CC and DD is not there.
Correct. Why? Because I
All
told you
the
it should be
elements
for
should
all
have
the
the
X.
mirror image.
Correct. If I'm taking, okay, so I'm taking another one.
So can we add the extra elements after that?
Yeah, you can add it. I'm just
In
taking the same
reflexive,
example,
you
whatever
can
you have
add
told. I'm
another.
taking, I'm just taking the other example that will clarify you. So if I have a, yes, that is AA, BB, CC, DD, and then you have AB. Is this a reflexive?
Yes.
Yes, sir. It's
It
reflexive.
is
Yes, sir.
reflexive.
Yes, sir.
Anybody has any doubt in this? Why this is reflexive? Anybody?
No, sir. No, sir.
No, sir.
Correct. See, AA, I told you only this condition for all X. I didn't told you anything about this AB and all. Correct. I just told you this for all X, if X is present, this is reflexive. I don't care about anything else. I just care about this X, that if X belongs to S, and if for all the X, if X is present, I'll tell that relation as a reflexive. Is this done? This reflexive, you don't have any issue, right? I'll just move to the other one. Just
Sir,
find
but I have
everyone.
one doubt, sir.
Correct. Go ahead.
Yeah, if it is reflexive, the pair AA, BB, CC, DD, it is present. And if it is irreflexive, if any pair comes, it is irreflexive, right?
No. See, if AA, BB, CC, DD is present, apart from this, anything else is present, that doesn't make it irreflexive, like not reflexive. It is reflexive. I have just one condition. I just told you, I have this reflexive function has a problem when from all these four, if any one is not present. If any other thing is present, doesn't have any issue. So I'll just repeat it again, this statement. See, if I have all these four things, AA, BB, CC, DD. Okay, apart from this four, if I have anything, I don't have any problem. I am reflexive. Okay, this relation R is saying. Okay, but if out of this four, if any of the four is not present, I am not reflexive. Okay, this is what it's trying to say. Is this clear now?
Yes.
Yeah,
Yes,
not
sir.
reflective, irreflexive, right?
What?
If it is not reflexive, that is irreflexive, right?
That I didn't define any word. Like, okay, I just told you not reflexive.
Okay.
Sir, this condition for a set S, A, comma, B, comma, C, D.
What you call that?
Sir, this condition only for S, set S, A, comma, B, comma, C, comma, D.
Okay, only these four are present.
Yes, sir.
Then it
This-
also is a reflexive, then it's a identity also, but I'll discuss that later. Okay.
Okay.
Yeah,
Sir,
that is
then
reflexive.
for-
If only these four are present, this is reflexive.
Sir, what if the numbers are?
What if?
We take numbers, sir.
If
And also,
every
let's just
will
come
not
up.
be here,
Okay,
it
so
should be
out of this
identity.
three, just tell me which of the following are reflexive and which are not. Okay, so
Second
just think of, do not unmute yourself and speak out. Just tell, like, just write it in the chat box.
R2, R2 is a reflex.
Sir, S is the
R2
relation.
is
No?
reflexive. Please write it on the chat box. Do not, I'll just ask some of you. If you have a doubt, then you can ask. Otherwise,
S
just
is the relation.
yeah, this is the question. You have the set S, right? A, B, C, D. From R2, R1, R2, R3, which of them is reflexive?
R2.
R2 and R3.
R2 and R3.
R2 and
Sir, is
R3.
that A1B or A, comma B?
Well, okay. Where? It's A,
In the
A, B,
R3. R3.
Okay.
A, comma B, right?
Yeah, this is A, comma B. Yeah, everywhere it's A, comma B. It's not A, B, B, C, C. Everywhere it's A, comma B. So I'm just writing it.
So it's R2 and R3.
R3 are reflexive.
R2 and R3, sir.
Correct. Anybody has any
R2
issue
and
with this? I'll just repeat it. Okay. If you don't have issue, I'll just move it to the next part.
Sir,
Yeah.
R3 here means R2, like we are taking the whole set of reflexive and then adding AB. So it doesn't make any sense. It will be reflexive now.
Yeah, correct. I just told you we have to apply the condition on X, where if X, for all the X, if XX is present, apart from this, anything else is present, I don't care. It's a reflexive. I just need this fourth term. Okay.
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 Okay,
So
sir.
if this is a
Thank you,
number
sir.
also, that is not going to make any difference. Let's, for example, I have S equals to 1 and 2. Correct? And I have a relation R5, and that is basically 1, 1, and then 2, 2, and then 1, 2. Is this a reflexive R5?
Yes,
Yes, sir. Yes, sir.
Yes.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Correct. So, okay. Can we move to the next part?
Yes.
Of course, sir.
Yeah, let's move to the symmetric one. So this is the
Yes.
second thing that we should be knowing. And this is like important, the most important part of the one.
So what is the difference between reflexive and identity?
Okay. So
Yes, sir. I have
the
also.
identity. Okay, I'll discuss that, but first let me discuss the symmetric and then transitive. I'll come to the identity. Okay, and then I'll tell. Okay. So the next part is symmetric relation. Okay. So in the symmetric relation, let's, for example, you have a R as a relation. And that R is a symmetric relation if and only if, here also you just read the line, and that is it for you to understand what is symmetric.
Yes.
So R is a symmetric relation if and only if for every. So here also there's a word that is very important. For every xy belongs to R, yx should be present. What did I say? For every xy, yx should be present. If even for one xy, yx is not present, that is not a symmetric. Okay? Is this clear?
Yes, sir.
Yes,
So
sir.
I have a S set 1, 2, 3, that the element of that set is 1, 2, 3. R1 is a relation. Is this a symmetric relation or not?
No,
Yes.
sir.
It is not
Yes, sir. It
No,
is a
sir.
symmetric.
It is a
Did I say?
relation.
Did I say?
Yes,
For,
sir. R1 is
It is a
identity.
symmetric. It is a
okay, how
symmetric
many of you are
R1.
saying symmetric? Just raise your hand.
R1. Just
R1, yes, sir.
No, sir, it's not.
It is symmetric, sir.
it is symmetric.
It is symmetric.
It's symmetric. How many of you are saying so? 15 votes has came for the symmetric. How many of you are saying it's not a symmetric?
It's not symmetric.
It's not.
Symmetric.
It's a symmetric.
No,
Not symmetric.
It's symmetric. It's
It
symmetric.
is
Okay, I'll
symmetric, sir.
discuss this. Okay,
Not
R is
a
a,
symmetric.
what did I say? R is a symmetric if and only if for every
XY should be
xy,
present. Sorry.
for every xy,
Or
which is
every, na,
belonging
sir.
to R. Okay, so tell me the xy for this R. So this is the R1, right?
1,
So tell me the first x1.
1, 2.
1, 2.
For 1, 2, 2, 1 is present or not?
Yes.
Yes, sir.
Correct. Okay. So the next xy is 2, 1.
2, 3.
1, 2.
Okay, 2, 1. For this 2, 1, what is the yx?
1, 2.
1, 2, 1, 2.
1, 2.
1, 2. Is this 1, 2 present?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Correct.
Yes,
Is this
sir.
whole statement? Did we check everything?
No,
From the
sir.
statement?
3 is remaining.
Okay. So for which xy you will get 3? Like where you will get 3? Is this 3 present anywhere in this R1?
No,
What did I
sir.
say?
Check for
R is
the
symmetric
relation,
if and
not the
only
set.
if. You see, what did I say? R is symmetric if and only if for every xy belongs to x. Xy
Yes.
belongs to R. So here the condition is on R, not on S.
Yes.
Earlier there was a condition on S. Okay, the reflexive. Here you have a condition on R. So you have to check for all the xy belongs to R, and if yx is present, then you can say directly it's a symmetric. Okay, you don't have to go through this 3 and 4 and 5, like whatever the rest elements are present in the S. You just have to check R1. If you have to check R1 as a symmetric, just go through each and every element. So if you are going to the first element, 1, 2, 2, 1 is present, yes. I'm going to the second one, 2, 1, 1, 2 is present. Okay. So this is int, right? Is there any other element? No. So for each and every element, for each and every xy, for this R1, yx was present. So this is symmetric, right?
Yeah.
Okay,
Is this
sir.
clear to everyone? Or should I
Yeah,
repeat
sir.
it again?
So,
Yes.
We got
Clear,
it.
clear, sir.
Okay. Okay. So then tell me, I'll just ask you some other questions also. Okay. You have the same S. And now you have relations like this. 1, 2, 2, 3, 2, 1. And then you have 3, 2, 4, 3. And then you have 3, 4. How many of you are saying is a
It is
Reflexive,
symmetric.
sir. Reflexive.
Symmetric.
It is symmetric. Symmetric,
It's
sir.
not symmetric.
It is symmetric.
It is
It is
symmetric.
not symmetric. For which
It is
xy you
not
are
symmetric.
finding? Okay, so if somebody is saying not symmetric, tell me that
Sir, why,
element
sir?
where you're not able to find that yx for that xy corresponding xy.
Symmetric.
For 1, 2, you are able to find 2, 1. For 2, 3, you are able to find 3, 2. For 2, 1, again, you are able to find 1, 2. 3, 2, you are able to find 2, 3. For 4, 3, you are able to find 3, 4. For 3, 4, also, you are able to find 4, 3. So you are able to find every pair, right? For every xy, you are able to find yx. Correct? If you are able to find that, you can say directly it's a symmetry.
Yes.
Correct?
Yes, sir.
So this relation does not belong to set S. So you're considering 4 as well in set S, right?
Yes, sir. It's not even a relation.
Oh, that's superb. Yeah, it's not even a relation from this S. Okay, correct. Yeah, you are correct. So if I have to write it, I should be writing here 4. Then only it will be a relation, first of all. Then
So
only it can be any
4 in set S.
symmetric or anything. Okay, if I'm writing 4 here, then it's a symmetric. Otherwise, it's not even a relation. Leave apart for the symmetric and reflexive. If we are not having 4 there, we can say this it's not even a like relation itself. Okay, because I told you, right? Relation is what? Relation is a subset of some Cartesian product that you are making. Okay. So now you got it, right? So R3 is a relation, or it's a, so basically we are reading about the properties of relation, right? It's a symmetric only if you were having each and every term or elements were present in this, correct? It can't be that some of the element is coming from some other space or some other sets and correct? Is this clear to everyone?
Yes, clear.
Yes, sir. Clear. Yes, sir.
Sir, I have a simple doubt in reflexive.
Go ahead.
Can I ask?
Yeah, you can.
So there is a x and y, and x minus y is equals to 0. So when 0 comes in subtraction, when we subtract that digit from that digit, so the output is 0. So it is reflexive, na?
I didn't get your point. Can you repeat that?
So there is a xy.
Okay.
Okay, and x minus y is equals to 0.
Okay.
So when we subtract that digit from that digit, means we subtract 3 from 3. So 0 is come. So x value will be 3 and value will be 3.
So basically, you're saying the difference of the two number is 0. So is this a reflection?
Yes.
It is.
And that
is identity also.
Yes. So that will be a reflexive, na?
Yeah, that is a reflexive.
Yes.
Okay. Let's come to the transitive relation. This is the last one and the most important one.
Sir, I
Yeah.
have doubt. Could you please call
Yeah.
the last one? This means in the definition of symmetric, you have not in the definition of symmetric, you have not mentioned anything about the set S.
Okay.
Then,
But what is this
how
R? This R is a relation on S set, right? So this I told you in the starting itself. So so I didn't define it everywhere, but I just told you R, whatever the relation you are making, that is you are making on some relation S, correct? So you are making some relation, correct? So you should be making a relation. If you are making a relation, that should be on some set, correct? So that should be coming from some Cartesian product. Is not it? Okay, and that Cartesian product is basically subsetting.
So for all the three definition, we have to check does that
it will be always there. It will always be there.
Means
Yeah, it will always
relation
be
is
there. We will not be finding any values. So by mistake, I just wrote it, but you'll not be facing any issue anywhere.
Okay.
Excuse me, sir.
Yeah.
Sir, if there is in symmetric relation, sir, if any element is same like 4,4 and 5,5, like sir in relation R3, if I have an extra element like 5,5, then what type of relation we will consider it?
Yeah, that is symmetric also, right?
It is still same, na sir. There is no difference.
No, there is a difference between what symmetric and reflexive.
Sir, like in R3 relation, sir, if all the elements remain same as they are, but there is an extra element like 5,5.
Then also it's symmetric because for 5,5, are you able to find 5,5? Because xy for 5,5, what is x and y? 5,
yes, sir, like
x is 5 and y is 5.
Yes,
is
sir,
that
like,
y and x present? 5,5 is present? Yes, then it's a symmetric, right?
Yes, sir. Like 5 for 5,5, we need not any other 5,5, no?
No. You don't have to add.
Okay, sir.
Sir, could you please repeat for I1? Is it symmetric?
Yeah, it's a symmetric. It's a symmetric. Why? I told you that. Okay, please mute whoever is this. So why did I say R1 is symmetric? Because the definition, just read the definition. R is symmetric if and only if for every xy belongs to R. I'm not making anything on S. I'm just telling you, just check R. I'm checking R. For all the x, for every x, so for the first one, 1, 2, is 2, 1 present. For the other one, 2, 1 is 1, 2 present. Okay, so if this is done for every xy, I can say these are symmetric. I don't have to check anything else. Okay. But here, so if here it was like 1, 4 was also given, was that a symmetry? 1, 2, 2, 1, and 1, 4 was also there.
No, sir, not symmetric. No, sir.
It should contain 4, 1 also.
Here,
4, 1, yeah.
That's a symmetry, correct?
Yes, sir.
Correct. Okay. Can we move to the next part, transitive?
Yes,
Sir,
sir.
I have one
Yes,
doubt.
sir.
Sorry. Sir,
Okay, go ahead.
Sir, in the
Sir, I have a
definition,
doubt, sir.
in the definition
Yeah,
given,
one by one. So first, go ahead.
The symmetric
Yes, sir.
relation we have given like x comma y element of R. So my question is like whether there is any chance that this definition might change in future, or maybe it's, for example, we have taken, or it is a static definition which
It's a
which
static definition. It will not change at all. This is the definition for symmetric.
Okay.
It's like,
and we will not be changing this.
I
to
have a
x.
question, sir.
it will not like, but yeah. So it will always
Could you
follow.
please
Could you
Sir,
please?
could you please explain asymmetric and antisymmetric also?
Okay, I'll do that. First,
Yes,
I'll just
sir.
define transitive and then only I'll discuss the
Okay, sir.
symmetric, that
Okay.
other part. Okay.
Okay, sir.
Okay. So transitive relation. Just read this once and then I'll define.
I have a question, sir. Hello,
Yeah, go ahead.
sir. My question is, how can we find how many elements to add to make a relation equivalence?
Okay. Do you know about the equivalence relation?
Yes, sir.
So please first explain about transitive, then you can move on.
Yeah,
Equivalence.
correct. So I'll just discuss this transitive and then we'll discuss the equivalence relation. Okay.
Because it comes after transitive.
Okay. So who raised their hand? I think so. 4 people raised their hand. Yeah, Akhil, Rakesh. If you have a doubt, you can just unmute yourself. Otherwise, you can just unraise your hand.
Hello, sir. I have
Yeah.
a doubt. Sir, a question from AQ 1.8. I've also sent you the image in the message.
Okay, I'll discuss that.
Okay, sir.
First,
Thank you.
okay.
Okay, sir.
Okay, so the transitive relation, if you have some R as a relation, R is said to be a transitive if and only if for every pair of element xy and yz belongs to R, xz should be present. So what did I say in the symmetric? If for every xy, yx should be present. Here, what am I saying? For every xy and yz belongs to R, xz should be present. Okay. So is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, I'll just ask you some
explain
problem.
the example.
Then tell me later. So most of the people generally find this a bit difficult. Okay. So I have a relation S 1, 2, 3, 4. And then you have a relation S R1. So there was a set S, and then you have a relation R1 where it is 1, 2. Okay. Tell me, this is a transitive or no?
Yes, sir, it is.
Yes, sir.
Yeah, it is transitive.
Yes, sir.
Yes, sir.
1, 2,
No, sir.
3. 1, 2, 2, 3.
Sir, can you
1,
explain why
3.
R1 is transitive?
1, 2.
Yes, sir.
Yes, sir. It is also.
No transitive.
No, it
R2 is
the
transitive.
R2 is also
R2 is
transitive
a
and
transitive.
R2 and R1 both are transitive, sir.
No.
No, sir.
R2 is a
No, sir, R2
transitive.
is not transitive.
1, 2 is there,
Let
but
me
2,
write
1
the
is not
question
there,
first.
sir.
Not transitive. R2 is not transitive.
R2 is transitive.
R2 is transitive.
Yeah.
Let me
why
write the
not?
question first.
R2 is transitive.
R2 is not transitive.
Okay,
It
let me
is.
write the question, please. Okay. Now tell me R1 is transitive or not?
Yes.
No.
Yes, sir.
No,
It is.
sir.
No, sir.
It's
Yes, sir.
It
Transitive.
is.
Yes,
No,
sir.
sir.
Raise your hand. How many of you are satisfied that this is a transitive?
Transitive.
Me, sir. It
No.
is.
Just
No,
raise your hand.
sir.
I'll just count it.
Sir,
Yes,
all
sir.
three are not transitive.
R3 is transitive.
Sir, all three are not transitive.
All three are transitive.
I'll just ask you the first one. So only 14 people are saying that this is a transitive.
Transitive.
So
And
can you,
how many of you are saying this is not a transitive?
Me, sir.
So this is a transitive relation, first of all.
R1 and
I'll
R2
just,
are
again, I'll
transitive.
just ask you to read this. What did I say? For every pair of element, and this is also a set condition on R, one not on S. So for every pair of element in XY and YZ, if XZ is present, this is transitive. If XZ is not present, then it is not transitive. See, one more thing. If XY is present and you are not able to find YZ, then what's the fault for this definition? So you are not able to find YZ. That doesn't make it not transitive, right? In that case also it will be transitive because not able to find YZ.
Yes.
Okay,
Correct? So for every xy and yz, so if you are seeing xy, any xy, just search for that yz. And if you are not able to find, then next move to the other xy. If you are
So-
able to find yz, then search for the xz. And if this xz is not present, then only you can say it's not transitive. Okay?
So
So
it means
let's
if
come to
xy
it.
is present and yz is not present, then
Sir,
xy is the transitive
Sir,
relation.
if XY
Then also it
present
will be
and
transitive
YZ
because you're not able to find yz, right?
Yeah, yeah.
Correct?
Okay, sir. Okay. Fine.
Let's come to it. For this first case, what is xy?
1, 2.
1, 2.
Are you able to find anything that starts with 2?
No, sir.
No, sir.
No. So is there any, like, from the definition, whatever we read, did we doing any mistake? No, right? We're not doing any mistake, correct? We just found xy. We are not able to find yz. So what can we do? It's like, if we are not able to find yz, you'll not be able to find xz also.
Yes.
Correct?
Yes, sir.
It's a transitive.
No, sir,
See,
it is
I
not.
told you if xy is present and then go for yz, and if you are able to find yz, then it is a must condition to get xz. Okay, and if you are not getting this yz, okay, then it's not necessary to find xz because you are not able to find yz itself, right?
Yes, sir.
Correct? So for every xy, yz, you should be getting xz. That is the condition here, not the any. So this is the only condition to satisfy for the transitive relation. Yeah, if you have any doubt, you can just.
No, sir.
Yeah, go
Sir,
ahead.
sir,
Yeah, go
please
ahead.
correct. Sir, please correct me if I'm wrong. So, sir, what you have told is that ki xy, if it is present, yz is present, then xz should be definitely present. And if xz is not present, then it is not transitive, now.
Correct. Correct. But if you're not able to find even yz,
then it is
okay, then,
transitive.
yeah, then you should not be searching for xz itself, right?
Yes, sir.
See, the R2. Okay, yeah. So the other one, whoever was asking, you can ask. So 4, 5 people.
Sir, I have a doubt, sir.
Yeah, go ahead.
Sir, can you please just explain the R1 once again? I couldn't understand.
I told. So for the to check transitive, okay, you just reply me. For to check for the transitive, what we say? We say if xy is present and yz is present,
Yes.
then that implies
XZ.
xz should be present. Correct?
Yeah.
If I'm just finding xy, I'm not able to find yz. What should we do now? There is no need to say it's not transitive. Like we are not able to find yz itself, so we not be searching for xz. Correct?
Yes. Excuse
Okay,
me,
sir.
sir.
Got it, sir. Thank you, sir.
Yeah.
Excuse me,
So
sir.
here, yeah, go ahead.
Sir, one question related to transitive.
Go ahead.
R is the relation defined the set of natural numbers, sir. R is two p power a and 2p power b belongs to a comma b belongs to natural number. Which relation, sir? Transitive या reflexive?
What did you say? Again, can you repeat that?
Suppose
you
that
have a b as some natural number, you're saying, right?
Yeah, a b some natural number.
Correct.
R relation 2p power a
2p power a
comma 2p power b.
Okay.
Which relation, sir?
Yeah. So just write it now. Just put the value, some random value, just take it, all the values, 0, 1. Okay. Then take it to the power 1, or 2. Okay. So if you're just taking this a, and you are taking a, b both as a natural number, right?
Here, what is
so
A
it
and
will
B?
take all the infinite values.
Sir, reflexive relation known as?
It will be taking all the values, right? A, B, all the natural number, correct?
Yes. Natural number, yeah.
So this is the relation. Let's, for example, I'm just taking AB as 0, 1, 2. Okay. This will be your relation 2 to the power 0, 2 to the power 1, to the power 1. Just this will be a smaller set that I'm taking. You have to just check it. So what would you do for the symmetry?
Reflexive relation as
What do you
same
check
to
generally?
reflexive relation, I think not.
No, I'm just asking you. For symmetric, what do you check?
Yeah, symmetric a comma b and b comma a belongs to R.
It should be belong if for every if there is 2 to the power 0 and 2 to the power 1, then 2 to the power 1, 2 to the power 0 should be present. This is what you check, correct?
Yeah,
Will
symmetric
will you
relation.
get for all the condition? Will you get here?
Okay, sir. Okay, sir. I am,
AB is like AB is natural number. So for some A it will be 0, for some B it will be 1, right? So for sure you'll be getting somewhere you'll be getting A as 0 and B as 1. For the other case you'll be getting A as 1 and B as 0, correct?
okay, sir. Thank you, sir.
So it will be symmetric.
Yes.
One first thing is clear. What do you check for the reflexive?
Yeah, not sir.
All the elements like A.
A element and B element as per the same element, but not reflexive.
So it will go to the infinity, no? Because A and B are the next.
Yeah. It will go to. I'm just taking a smaller set.
Yes, sir. So if it go to infinity, then it is reflexive, and it is not defined, so it is an reflexive also. I mean to say that AB is as a set is defined that AB as a natural number, but it is in a
natural number included, na sir, 0.
Yeah, it will include 0. I'm just telling you, if there is no order of this natural number, you can get any values, right? A and B can. So one place if A is 0 and B is 1, so the other place you can get A as 1 and B as 0, correct or not?
Yes.
Yes.
Correct.
Yes.
That means what, in that relation R, whatever you are making, you'll be getting 2 to the power 0 also with 2 to the power 1 and 2 to the power 1 with 2 to the power 0 also you'll be getting.
Yes,
correct?
sir. Yes, sir.
Okay.
Because there is no fixed order of A and B.
Yes, sir.
Isn't
Yes,
it?
sir.
And if you're not, because A is equals to 1 for the other case and B is 1, then for the other case it can be A equals to 1 and B can be 0.
Become 0.
If this is the case, you can get this as symmetric. It can be reflexive also, you need to check that.
Yes,
because
sir.
you can get it, because for A also you can get 0 and B also you can get 0.
Because
Right? So 2 to the power 0 also can be present and 2 to the power 0 can be. So for all the other cases also it will be present. Right? And what did I say? For reflexive, what should be present? Only you just care about this thing. For infinite, because it will be for all the infinite value, you'll be getting 2 to the power 0, 2 to the power 0, and similarly for the till 2 to the power infinite, right? So all the things you'll be getting, correct?
Yes.
Okay.
Sir.
But it is not symmetric.
What?
But it is not symmetric.
It can be any relation, na sir?
It will not be. What did he say?
Not equivalence relation. Only for transitive relation and symmetric relation.
So for the again, you have to check for the transitive also.
Yes,
so where
sir.
is this
Transitive.
question? Just tell me. I'll just maybe you are just making some mistake or what. Where is this question?
Question suppose R is the relation defined the set of natural number.
That I got. From there only I was reading. Maybe
Which relation? Which relation? No. Question is correct.
No. Question is correct. Whatever you said, according to that, it will be symmetric also. It will be reflexive also.
Symmetric and transitive, sir. According.
See, why not reflexive? See, you just told me what? You told me A and B is a natural number. Can be anything, right? A natural number means what? It will include 0. It will be from 0 to infinite. Anything, correct?
Yes. But sir, order maintain. Sir, relation
so
order
then it will
maintain.
not be okay. If the order maintains, it will not be reflexive.
Yes.
Because,
So it is an equivalence relation, no?
No equivalence relation.
Why? Because when we put it as natural numbers as A and B 0, 0, so we will get
because
0.
reflexive relation not coming. Only for transitive and symmetric relation.
He told me A and B are different different natural number. And if you are taking A and B, how can it be same? Like you can't take A as same as B, right?
Okay,
If
sorry,
it
sir,
is
I
different,
didn't listen it.
it's not a reflexive, correct?
Yes. Okay, sir. Thank you.
Can we move to the next part, transitive?
Yes, sir. Please move to the transitive relation.
Yeah.
Sir,
So in
what
that,
will be the domain and range for this?
I didn't discuss anything about function till now.
Third set will be not transitive, na?
Yeah. So the third case is what?
Transitive, sir.
It is transitive, sir.
It is transitive.
It is transitive.
It's not
It is
transitive.
transitive, sir.
Non-transitive, sir.
Not transitive.
Sir, because
Non-transitive.
4, 4 is not present, and also 4, 2 is also not present.
So we
Yeah.
don't have to see for 4, 4, sir. We have
Why? See, I told you what,
R3 is
if
transitive.
xy is present.
1 is present.
Sir, it is present 1 2 2 2 4. It is 1 4 and 1 4 4 1
Yeah,
1
so you have
1.
to check for
Yes,
each and every
1
case.
4 1 1 is present. For 1 4 4 1 1 1 is present, sir.
For
Correct.
4 1 and
See,
1 4 4 4 is not present.
yeah, this is what I told.
Yes,
For
sir.
1
4
4
1 and 1
3.
1.
Okay,
But
see,
it should hold for all
if I am
xy, no?
having this
Answer.
as xy and this as yz, where is this xz for me?
1 1.
1 1 is
It is
present.
there, sir. 1 1.
Not transitive.
1 1 is present. Right. So for 2 4, if I am this one as xy and this as yz, do you have 2 1?
Yes, sir.
Yes.
Similarly, you
Yes,
check,
sir.
but I think so. This is transitive. This is also transitive.
Yes, sir.
Yes, sir.
Also
The
transitive.
2 is not present here.
But sir,
No,
for
sir.
4 1 and 1 4 4 4 is not present, right?
For 4 1 and
1 4.
Sir, similarly, 4 1 and 1 2, if we will take, then 4 2 is also
Yes,
not
sir.
present.
Yes, sir. So there are two conditions for it to be not transitive.
Yeah.
Yes, sir.
yeah, correct, sir.
Sir,
So
if
if I'm
you
taking
take 4 1.
Sir,
this
excuse
as
me.
So we
xy,
have to look
and
for
this,
the vice versa also, right?
yeah, you have to check
We
for
have
all
to
the
look for each pair. For every
Sir,
pair.
Like
actually,
4 1 you have to check for like 1 4 is there, but 4 4 is
Sir,
not there. So
Correct.
sir, please
excuse me,
check 4
sir.
1 with 1 2.
Excuse me.
1
I'm
2.
only one
Yeah.
doubt. Actually, in the set, how could we consider which is X, Y, Z like that?
No, for
Based
each
on
and
that only
every
we are
thing you have
deriving.
to check. See, for any, so you starts with here, this is xy, and just check with how many values are starting with y or 4. Just go through, scroll and check it, like go one by one. So you got it here, right? So this is your
Yes.
yz for this xy. And then check, is this 4 2 1 present? Okay, 2 1 is present. Then go for the next. Similarly, you check for each and every pair. Okay, like this is very big, so you are getting confused. But I think so. This is not transitive for one case that I can find it. For 4 1 and 1 4 4 1 4 1 4 4 is not present.
So for 2 1 and 1 2, 2 2 is also not present.
Sir, is there any order of considering the alphabets based on that set given? If
there's no
someone
any
is
order.
considered different order, then relation could not be reflexive or not like that. A transitive is not. For example, someone is taking x as 1 and y as 2 and z as 3 like that. If I am taking something as x, y, z as something value, some other value, then how could we take that answer will be same for everyone consideration?
See, how did I start? So 4 1 you took, right? 4 1 I took as xy. Correct? I'll just check for which of the values, for which of the element it starts with 1. So I can find it 1 here. I can find the other one here, right? So if I'm finding it 1 here, so I'll be checking for 4 1, correct? So 4 1 is present, but I'll check for 4 4 also, correct? Because if I just fix it xy as this one, I'll just check for the other cases where yz is present, right? If I'm starting with x1 as 4 1, where x is 4 and y is 1, I'll check for, what did you say?
And that's what I have confused. If the values are taken differently based on each and every person, and that relation
Just
will
start with
be
one value and scroll for, if you are checking for the first value as xy, you just see for how many elements you are getting y as a starting point. If you are having xy and if you are able to find y as a starting point for some 2 elements, then for you have to check for both the cases xz, right? You'll be having a z1 and z2, correct?
Yes.
So for both the cases, this xz1 and xz2 should be present. If one of the cases is not present, you can directly say it's a non-transitive. You just have to find one case, and even for one case it's not satisfying, you can directly say it's not transitive. Okay.
if at least one case is present, it is transitive, right?
Even for one case you are not able to find, you can directly say, because you have to check for each and every pair. Correct. So you just have to find one pair where it is not satisfying. Okay, and if you are able to find that, you can directly say it's not transitive.
So then this third one is not transitive, right? Because for 2 4 there is no 4 2, no?
Which one?
No, 2 4. But xy is there, so we don't have to look for y.
Excuse me, sir.
Okay.
So R3
Hello,
is
sir.
not transitive.
Can we
Okay.
just
Sir, I have a doubt, sir.
R3 is not transitive. And I told you the reason. For 4-1, you have to find, for 4-1, can you find how many values are there which starts with 1? This is the one, and the other one is 1-4, correct? So you are
Yes,
able to
I
find
got it,
4-1,
sir.
but
Doubt is clear.
4-1, you are able to find 4-1, but for 4-4, you are not able to find 4-4, right? So if you are not able to find one cases, I told you, it's directly, you can say directly it's a not transitive.
Sir, that
Excuse
agree,
me,
but
sir.
sir, that
Sir,
agree.
so we have considered like 1-4. Like one case we can, anybody can consider XY. Like I have considered XY 1-4, and anybody has considered XY as 4-1. So for that case, 4-4 is not
No,
there.
you
So it
have
will
to
be not.
consider both. This is what I told. So you have to
Okay.
check. So you have to check if
So we have to
if
check
this
for
was
vice versa, na, sir. That means in short, like.
no. See, if there is so okay, just tell me for 2-4, you should be finding the value which starts with what? 4, correct?
4. Yes, sir.
How many are values? You just can see only one values, right? 4-1.
Yes,
What
sir.
should be the next target? You should be checking for 2-1, right? Because 2-4, 4-1. So 2-1 should be present. Correct?
Okay. Yes, sir.
Similarly, for 1-2, you should be searching for which value? That starts with.
2-1.
So how many values that starts with 2? This one and the other one
1.
is.
Yeah.
Okay.
The
So for
same
1-2,
for
2-1,
2-1
1-1 is
also.
present. For 1-2, 2-4, is this 1-4 present? Yeah, 1-4 is present. No, go for the 1-4, right? Just check for how many of them are starting with 4. So you can see that. And then similarly,
Only
continue.
one. Okay, sir.
Do you have any problem now? Just tell me.
So for 1-4, like 1-4, 4-1, 4-4 is not there. So that's why we are not considering it as a transitive, no?
Correct. Can you find
Okay,
another one? Can somebody
And
find me?
also there is a 2-1, 2-1, 1-2,
Sir, for
and
4-1 and
4-2 is not
1-2,
there.
4-2 is not there.
And so for
What?
also 2-1,
4-1, what is
1-2.
that?
4-2
For
is not
4-1.
present.
Yeah, correct. For 4-1, 1-2 also 4-2 is not present, right?
Sir, also
2-1, sir, also 2-1.
for 2-1 also there. 2-1, 1-2,
1-2. But
and
2-2
there
is
is
not there.
2-2 is not there.
Yeah, so for so many values, this is not present. So you can directly say this is not transitive. Okay.
Yes, sir.
Sir,
I
can
have.
we just
What
move
about
to the
ortho?
equivalence relation?
Yeah, so if somebody is like satisfying all the three conditions, you can directly say it's equivalence. This is what equivalence is. There is nothing special.
Sir, what about R2, sir?
What about?
R2. Second one. 1, 2,
R2 is transitive, right? Can you
So
find anything?
that 1, 3 and 1, 4 that has that doesn't has the second pair, so it is transitive, right? We are unable to.
Yeah. So second pair, if the second pair is not present, there is no issue in that. I told you for each and every case, so for symmetric, you should be searching if for every xy, yx should be present. For transitive, for every xy, yz, xz should be present. Okay. And if you're not able to find yz, there's no concern. Like I'm not discussing anything about, I don't have any problem. Transitive saying, if you are able to find xy, yz, then find xz. If you're not able to find yz, then don't go for xz. Okay. Only if you are able to find yz corresponding to xy, then only you should go for xz, search for xz. And if that is present, well and good, go for the next term. And if this is not present, you can directly say it's not transitive. So just I need one case where this is not satisfying. And for one case, if it's not satisfying, you can directly say it's not transitive. But for being a transitive, you have to check for each and every cases. Okay?
Okay, sir. Sir, on second and third relation, for the 2, 1 set, I can find 1, 2, but 2, 2
Your
is not
voice
present.
is very low. Is this from
Hello?
my side or your side?
No, it's from my side. Sir, for this last set, 2, 1.
Okay, for 2, 1, what did you say for 2, 1?
I'm able to find 1, 2, but 2, 2 is not present, so it is not transitive. But in
Yeah,
another
you can
case,
directly say it's not present, then it's not transitive.
in another case, if I take instead of 2, 1, 2, I take 1, 4 means 2, 4 is present.
No, but what did I say? For each and every case you have to take, right?
Yeah.
For each and every xy, if you have 2y that starts with, if you have 2 elements that starts with y, then you have to check for xyz, xz1 and xz2 both. It's not that you are just checking for one cases. You have to check for each and every case. Okay? Is this clear now?
Yeah, in second case it is matching, so it is transitive, right? If
Yeah,
I
yeah. The
take
second one is transitive.
yeah.
Okay, should I give more example of transitive or should we move to the other part?
Can move to the next one function.
We'll move forward to
Or
function. To
antisymmetric.
the next
Or
part. I have a
this
doubt
function.
in function actually.
If you have a doubt, just ask me. If you don't, I'll just move to the other part.
I have the doubt.
Yeah,
So
go
for,
ahead.
so for the transitive, we need the three. So I have a
Element.
question. Three cases. For the transitive, we need three cases. Agree?
Not agreed. See, three cases. What do you mean by three cases?
I mean 1, 2, 2, 4,
1,
and
2.
2, 1.
So what did I say? If you are able to find, if you have 1, 2,
yeah,
then what you should be searching for? You should be searching any element that starts with 2.
Yes,
if
sir.
you are not able to find any element that starts with 2, there is no problem in the transitivity of this relation. Okay.
Then it is transitive.
It is transitive, but for the first, according to the first term, it is transitive. Now go for the next term. If you are not able to find for next term also, then go for the third one. And similarly, if you're not able to find for any of the cases, it's a transitive. Okay. You don't have to bother about. But if you are able to find y, any element that starts with y, then you should go and search for xj. And if that is not present, then you can directly say it's not transitive. But if that is present, you should go for the next term.
Okay, sir, in the R3, 2, 4 is there. After that, we will find that 4 is there. So 4, 1 is
2,
there.
4 is there. You should be searching for someone like element that starts
4,
with
1.
4. Correct?
Yes, sir.
4,
So,
not 4, 1. Starts with 4.
Starting with 4.
What is the element? 4, 1.
Yes,
If
sir.
that is present, what did I say? If xy is present, yz is present, you should search for xz. So here, what is your xz?
2, 1.
2, 1. Is 2, 1 present?
Yes, sir.
Present. So for this case, for the first one, it is transitive. But you have to, what did I say? You have to check for each and every element, right? So now go for the 1, 2. Now your x is 1 and y is 2. And search how many of them are starts with 2. You can see that the 2, 4 is also starts with 2. The last one is also starts with 2, right? So now you have 2, like 2y, right? Now for both the cases, it should be satisfied. Now go for the 1, 4. Check for how many of them starts with 4. Similarly, you do for all the other cases. Okay.
Okay, sir.
Is this clear?
Excuse me, sir. Only one thing. If it's so, we have to look for the transitive. Even only the S elements have three. Sorry, S set has 3 elements. If it is less than 3 elements, we could not go for a x, y, y, x, and x is should be present.
No. See, it can be 2 element also, right? 1, 2. And if this is 2, 1.
Yeah, I'm
right.
not asking about the relation. I'm asking about the S. That S set should have is having 1, 2, 3, 4, right? If it is having only 1, 2, only 2 elements, can we take the relation by transitive like that? How can we consider the Z?
Okay, so if we are saying this S is a set, in this set, what would be the Cartesian product of this S? That will be Sx cross S, right? So we'll be getting some bigger set, right? That will start with 1, 2, 1, 1, 2, 1, 2, 2, something like that, correct?
Yeah.
Now on that Cartesian product, you are making some relation, right? This is a bigger relation. This is a bigger part. You're making some small relation, correct? And then you are choosing which of the property will satisfy, right?
Yeah.
And then you can check it which of them is correct, like which of the following properties.
Sir, it's getting late, sir. Sir, please go ahead to function.
Okay. Transitive is done, right?
Yes, sir, done.
Yes, sir.
Yes, sir, we can go
Excuse
ahead.
me, sir.
Yes, sir.
Yes. I have
Hello?
a doubt. Excuse me, sir.
Yes, sir. Go
Excuse me,
ahead.
sir.
Yeah, go ahead.
Sir, one dot is set L1 or L2, L3, L4 set, but L1 perpendicular to L2. Transitive relation, yeah, not transitive relation, sir.
So if two lines are perpendicular to each other.
No, set, sir. L1, L2, L3,
it will be
L4.
transitive. It will be transitive because if L1 is parallel, no, it will not be. See, if you have a
perpendicular, sir.
Yeah, this is perpendicular, right? L1 is this one, L2
Yeah.
is this one. Correct? And if you
Yes, sir.
have L2 and
Set.
L3, this is L2 and this is L3. L2 and L2 is also perpendicular to each other. So will L1 and L3 perpendicular to each other? No, right? No.
Yes, sir.
Correct? So L1 and L2 is parallel to each other. So that's why it will not be a transitive.
No, sir. No, sir.
What? Did I make any mistake or what?
Sir,
Part function.
Sir, L1 and L2. This is the
L1, L2 is perpendicular to each other. This is what you said. And then
yes.
L2 and L3 is perpendicular to each other. So if L1, L2 is present, right? And L2, L3 is present, then L1 should be present, right? But L1 is not perpendicular to L3, right? It's parallel to each other. How can it be transitive, right?
Not transitive, no.
Yeah, not transitive.
And so it would also be not reflexive, no?
But sir, parallel to
Yes,
this is
sir.
the
Parallel will hold.
transitive.
Parallel will hold.
Yes. Okay. Sir.
So if we take the same conditions like L1, so for example, L1 is perpendicular to L2, so it will not be reflexive, na sir? Because like
For reflective, what do you need?
like L1 should be perpendicular to itself, and it is not possible. L1 will be parallel to
Not
itself,
possible.
na?
Yeah.
Okay, sir.
Okay, so what is left now? Symmetric. So you were asking about the asymmetric and then antisymmetric, right?
Hello, sir.
Yes, it is now.
Antisymmetric, sir.
Sir,
Yeah.
can you also explain about modulo arithmetic?
Those are like pretty simple. Okay, so you can just mail me about that if you want to know about those things. You just write it in
No,
my
sir.
mail ID, everyone. You can just, if you have any other doubt now, apart from this session, you can just mail me. Okay?
Sir, they gave that in the PPT, in the online lecture.
What are you saying?
Sir,
Okay.
they gave that content in the online lecture and we are unable to understand what was that, like
This is what
equivalence
I'm
class
saying.
and all.
This is what I'm saying. You can just mail me about that. Okay, I'll just write there. Okay, but after this, if I have a time, I'll discuss that. Okay,
Okay, sir.
If the session gets over, you can just ask me there also. This is what I'm saying.
So please
Not like
share your mail ID, sir.
yeah. So this is what I'm saying. If any of your doubt is not getting clarified in this session, you can just ask me there also. There's no issue in it. So vishal@study.iitm.ac.in.
So please can you repeat it again?
I'll write it in. Okay.
Sir, I'm having an issue with logging into Discourse. How to do it? I can't understand that thing.
So you're having issue in
logging in with Discourse thing that in the
So-
I'm not getting how to do that.
so you're qualified student, right?
No, sir, I'm a foundation.
Yeah, so this is what somebody has wrote. Prakash is wrote correctly. Nice. Okay. So now we'll study asymmetric and antisymmetric. So what is the opposite of symmetric? Can somebody tell me the opposite of symmetric? Is this the antisymmetric or asymmetric? Which one is the opposite of
Antisymmetric.
Excuse me, sir. But anti-symmetric not na syllabus, sir.
Oh, sir has
But
taught
somebody
us.
is asked, I'm just discussing. It's not there, but okay. If you are asking, I'll just discuss it in the line.
So
That
in video,
important,
sir has
nobody's
taught
going
us.
Okay, sir.
Huh?
In video, sir was teaching us like anti-symmetric, but we couldn't understand like much.
Okay, I'll just tell you. See, a relation is antisymmetric if this holding these two conditions. Okay, and what is that condition? I'll just write it here. So I haven't written it because I thought it's not that important, but okay. It's like a bit confusing, but okay, I'll write it. The two condition, I'll just write it. The first one is what? For all x, xy, that belongs to some set x. Okay, and what is the other condition? Okay. Maybe I'll give you some example, I guess. And so better to give you example.
Yes, examples are better than this.
Yeah, antisymmetry. So this is antisymmetry. The first is So example is, my R is this one. 1 1 1 3 3 1. If anybody of you know about the antisymmetric, tell me whether this function is this relation is antisymmetric or not.
Not, sir. It is a symmetric, not the anti-symmetric.
Symmetric. It is not symmetric also.
It's not symmetric, sir.
It's antisymmetric. Why? I'll tell you. See, for antisymmetric, what do you check? You check if for any of the cases, if xy is present and yx is also present, then there is only one condition that should hold, that x should be equal to y. Okay, yes, what did I say? It will follow if xy is present and yx is also present, that can be only possible if x is equal to y. And if for all other cases, if this is holding, this is not antisymmetric. Okay.
Sir, can we say that it is reflexive and symmetric?
Not opposite of symmetric. That is pakka. Okay. See, if we have 1 1 and 2 2,
So
is this
how
antisymmetric?
this relation is anti-symmetric?
And this is
R1?
symmetric also. Is this
Yes, sir,
symmetric?
symmetric to have.
No, symmetric.
It is symmetric,
It's
sir.
R1 because there is
Sir,
sir, both of them
Is
are
reflexive,
symmetric
sir.
as well as anti-symmetric. So both
This
of
is
them are
symmetric as
related.
well as
One
is
antisymmetric.
the
Both.
anti-symmetric meaning is that if A comma B is present, then B comma is not present.
See, relation R. So I'm just saying this statement for antisymmetric. Relation R of a set A is antisymmetric if AB is present and BA is present, then only one condition should hold. A should be equals to B. For all other cases, it is not antisymmetric. Okay. So what did I say? If AB, so here A is 1, B is 1. Okay. And if BA is present, what is BA? If 1 1 is present, for that 1 1, what should the BA, the opposite of that 1 1, right? And that should only hold if 1 is equals to 1. So here 1 is equals to 1, that means it will come under antisymmetry. Is this clear to everyone? So for the R1, for 1 3, 3 1 was present, right? So for 1 3, 3 1 was present. And if 1 is equals to 3, then only it will be antisymmetric, right? But we already know that 1 is not equals to 3. Is this clear to everyone or not?
So R1 is not
Sir,
antisymmetric.
It is not antisymmetric.
Sir,
Yes,
is
sir,
it
it's clear
important
now.
from the point of view of qualifier? Like, is it important to?
Like if this is taught in the, I can't see any problem for the
No,
last
sir.
3
Not,
terms.
sir, not
in
syllabus, sir.
the-
Anti-symmetric, not syllabus, sir, because of PPT book not included. And I am IITM
So
mail
it's a bit
regarding for the not
confusing. So,
included.
sir, can we leave it? It's a
I
bit
have seen any
confusing.
question, but okay, if you have a doubt, you can just ask. So what did I say? I just not
Sir,
that
but sir,
difficult also.
asymmetric is there, right, in our syllabus?
Asymmetric is a different. Okay, asymmetric also. See, if
Yes,
this
sir.
covered in the lectures.
But
Sir,
in the exams, there are not any questions of
Just save
anti-symmetric
it
and
and move to the
asymmetric.
next
Sir,
part, which is function.
only for sir reflexive
Sir, move
relation,
forward
symmetric
to
relation,
function, sir.
transitive relation, that equivalence relation.
So in
Not A
syllabus,
relation and
technical
anti-symmetric
asymmetric.
relation included.
So just move to the next part, which is function.
Yes.
So
So
is
can
this antisymmetric at least clear to you, everyone?
so for
No,
antisymmetric,
sir.
take just one
Yes,
example.
sir.
Antisymmetric is clear.
रेल लगा के गया था.
An
No,
opposite
it is
of
not
symmetric.
clear.
Yes, sir. Sir, I have a
Just
doubt on
repeat it
antisymmetric.
again.
So can you explain it with an example?
कल का पूरा हो
Yes,
गया ना.
this is what I give. Okay, so I'll just give you another example. Hold.
Yes,
Please.
sir.
Okay. So for antisymmetric, what did I say? See, if xy is present, if xy is present and yx is present, then there should be only one condition to be this relation as antisymmetric. That what is that? X should be equals to y. That means what? See, for this case, xy is what? 1 1. What is yx for me? 1 1 1. And here x is equals to y, right? So for this case, it is antisymmetric. Again, you will check for 2, 2, it is antisymmetric. But if I have 1, 2 and 2, 1, is this condition holding? For me, xy is 1, x1, x and y is what? 1, 2. Yx is what? 2, 1. And is 1 is equals to 2? No. That means what? It is not holding my condition, whatever I said.
Yes, sir, got it. Sir, so 1, 1, 2, 2 will be antisymmetric but not symmetric. Like any relation.
Symmetric and antisymmetric. So what did I say in the starting? Antisymmetric is not opposite of symmetric.
So a relation can be both antisymmetric and symmetric at the
both.
same time.
Correct. Always this type of function where you have a symmetric, like identical function, no? Those will be.
Yes. Yes, sir.
Sir, can
Okay,
you
sir.
say that every reflexive is antisymmetric?
No.
You can't say about that. But every identical you can say.
Every identity, I think
simple.
every identity is.
Sir,
Can we
antisymmetric.
Move to the next part function.
Yes, sir. Please, sir. Can we move to functions?
Please move to the function part. Yes, sir.
Yes, sir.
Can you
Please.
move the function?
So
Can
much
we?
doubts, sir.
Is it done? Relation is done. Is it clear to everyone? Each and everything.
Yes,
So
yes,
first
sir.
of all, clear
Yes,
the
sir.
concept of
Yes,
function
sir.
and
Move to the
all the
function
doubts
part.
one by one.
Yes, sir.
Yes,
Okay,
sir.
let's
Yes, sir.
move
Antisymmetric
function.
is clear now, but could you please clear also asymmetric as well?
Yes, sir.
Sir, afterwards, sir. Please, sir. After after
Please
clearing
clear
the
all the
function.
concepts which are covered in syllabus.
No,
and
sir,
clear the doubt one by
relation
one
completely.
last of the lecture.
Yes, sir.
Yes,
Sir,
sir. Yes, sir.
afterwards,
Last
like
of the lecture, we
yeah.
can revise, sir.
So please cover all the concepts that are
Sir,
covered
we
in
can
that.
go for function, please. It's already
Please
time.
move toward the Yes, function. sir, go to function, sir. Please, sir. There is so much doubts actually.
One statement I can tell about the asymmetric is what? Asymmetric is opposite of symmetric. Okay, not antisymmetric.
So just give an example. That's all what I need.
See, if 612 is present, okay, if 612 is there in R1, and if 12 6 is also present, then you can say it is not asymmetric. 1 2 is present.
Okay, fine, sir.
So then 2 1 should not be present for asymmetric.
Okay, sir. Fine, sir.
Got it?
Sir. Yeah.
Got it. Yes, sir.
Yes.
So move
So sir, we can say that as a relation can be asymmetric and transitive also.
Asymmetric and
Just move to the
transitive.
Yeah, that you have to check it, but I can't technically say.
Yes, yes, sir.
Move to sir function, sir.
Yes, sir. Yes, sir.
So please move to the function and clear all the doubts of the students in the last of the lecture. Yes, sir. I have also so much doubts, sir. Please don't.
Okay, let's
I
move to
have
the
a doubt, sir.
function. Okay, what is that? Just briefly, what is your doubt?
Sir, my doubt is how to find how many elements to add to make a relation equivalence.
Okay, that I'll discuss. Don't worry about that. Okay. See, there's no fixed formula for that. You have to do it piece by piece, like question by question. Okay. So every question, the number will be different. Are you getting my point? Because for every set S, for Cartesian product S, or for from where you are making the relation, there can be the number of term can be different, right? Correct? And
So
if
sir,
you
we
have
have to do it manually.
So see, there's no fixed formula for that, right? If you have been given some 2-3 terms, you can directly count it and then say. You have to make it like nobody is going to ask you like how many numbers you should be adding. Like there will be some simple trick to do that, right? If you'll just give me the problem, I can tell you how to do that. But there's no fixed step or formula to count the number. Okay, each and every question will be using some different concept to solve. Okay,
sir.
So please can you move to the function part?
Yeah, we'll move to the
Yes,
function.
Please, sir.
Sir, I have a doubt in activity 11, sir.
Okay, I'll discuss that after 10:30. Okay, your doubt. Okay, I'll just take your activity doubts for some 15 minutes and then we'll wrap. Okay.
One suggestion, sir. If we can just go through all the function topics first and stop all the doubts, and then let's clear all these things at the end of that doubts. Everybody can take a note of their doubts in a sheet of paper, and then they can just go ahead and ask later. because it is it would help us all.
Yeah, sir.
Yes, sir.
See,
Yes, sir. Yes, sir.
function is a relation
Yes,
in so this the such a statement as I wrote it to make you see only this two word that I wrote it, that is enough to understand the function. Many to one is okay, but one to many is not okay. Did you get the point? What did I say?
Yes, sir.
Many to one is okay
Yes,
means
sir.
what?
Yes, sir.
If you have a two function, you are making a relation between some set A and set B. From A, many you can go to one term of the B, but you can't do the opposite. Is this clear, or should I draw some drawing?
It means one function can't give two values. And one input can't give two values.
One input can't give two values. This is what I'm trying to say. But you can conclude to one value from 2 points. This is what I'm trying to say. See, I have a. Did I make any? Yeah. So So just tell me this one. The first. Is this a function? The first one I just wrote it, but okay. I'll just remove this. Okay, I can't remove that also. Okay, the first one, the first case.
No, sir,
Is this
it
a
is
function?
not.
What did I say?
No, sir. No,
sir. No, sir. Not
No,
function.
Why? Just tell me the reason also.
Because
It's not
Sir,
like
1 and 2
because
are
that
having
A is
Because
linking
domain
to.
is
There are two
repeating.
results.
Sir, it can't be one to many, sir. That's why.
what did I say in the
Sir,
starting?
1 and 2 are having the same pre-image as A.
I told you one to many is not okay. Many to one it can go, but one
Yes,
to many
sir.
can't go. Okay? Okay or not? If
Yes,
a
sir, got it.
parabola,
Okay.
if I'm drawing a parabola like this, is this a function or not?
No, sir. This is not
No,
function.
sir.
Not a function.
Why?
Because
Because
that
if I'm taking some
vertical
particular
line
value
is-
x1, for x1 I'm getting two values, right? This has
Yes, sir.
y1, this is y2. And what did
Yes,
I say? For function, you can conclude from 2 points to one like point, but you should not be going from 1x to 2y, right? So one to many is not okay. The second case, is this a function?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes.
Yes,
This
sir.
is function.
See, if you have been given any, okay, so can somebody tell me if you have been given any graph, if you have been given, how can you say directly without doing anything? If you have been given any graph, something like this. So there is some horizontal test or vertical test. Have you heard about that?
Yes, sir. Yeah.
No,
Vertical line test or horizontal.
Vertical line test for checking whether it is a function or not.
If there's
Yeah,
a
so if you are
two
drawing a
points of
vertical line,
test, then it's
and if this
not
is
function.
crossing only one point, then you can directly say this is a function, right?
Yeah. Yes, sir.
Yes, sir.
Yeah, because this
Sir,
is
can you
vertical
explain again?
See what did I say? If you have a graph, and if you're just plotting a vertical line, and if this vertical line is just crossing at one point, not more than 1 point for that graph, then you can directly say it's a function. Okay? Is this clear to everyone? For the graph, if you have been given a graph, you should be able to know, right? Okay. Tell me for this function, is this a what should I draw? Okay.
No.
Yes, sir.
No,
It's
sir,
a
it's
function
not.
for a
It's not a
horizontal line.
function.
A vertical line.
It's
How many
not
times
a
is
function.
crossing the graph?
Not
It is a
Not a
function for
function.
horizontal
Three.
line.
Yeah.
Function for horizontal
Do
line.
not say like this is a function for horizontal line. I'm just asking whether it's a function or not.
No, sir,
Okay,
it's
no,
not
sir.
a function.
No, sir, it's not function.
Because it's crossing at 2 points, right? You can directly
Yes,
Yes,
sir.
sir.
Got it. So I think so. This is clear to everyone. What is function?
Yes, sir.
Yes,
Yes, sir.
As that we have read about the relation, 4 features of the relation. Similarly, you'll read. So whether I've read anything. If a function, there should not be any 2 pairs with same elements. Okay, so this is what I have just wrote it. Type of function. So you basically have 2 types, injective and what is the
Sir,
other
can
one?
you just explain about domain and range?
Injective and surjective.
I'll
Sir, I
explain
have
you.
a doubt actually how to find domain and range. So
Yes,
I
sir, it
don't
is
know
clear how to find domain, range, and codomain.
Yes, sir. There are
Same,
so
sir.
many doubts in activity questions.
Okay, I'll discuss that for sure.
Sir,
First,
if
this
the function is injective and surjective, then it's called bijective.
yeah, got it right. But okay, tell me first, how will you check whether it's an injective function or not?
So we'll equate both the functions
If
and then we'll
each
see if
element of
x1
X
is
is
equal
mapped
we
to
will
the
equate
distinct
it
elements of
X1
Y.
are not equal
and
to x2. If
Distinct
the
element
function
maps
of
to
x1
distinct
is equal to
elements in
fx2, then it
equals.
is a 1, 1.
Yeah, so injective
If
function,
function is 1 to 1, then it is injective.
these two line is important. Many to one is not present, should not be present, many to one. From many points, you should not be going to 1 point. And from 1 point, if this is satisfying one to many, then there is not even a function, right? This is what I told you in the starting, correct? Correct or not? If this is going
Each
from one
image,
to
each
many,
image has a distinct pre-image. Yes.
what?
There
Each
should be
image
unique
has a
output for
distinct
every
pre-image.
input, no, sir?
Yeah, this is what I showed. One to many, if this is satisfying, that means it's a not even a function. Okay, so if this is satisfied, it's not even a function. What you have to check is for injective function, many to one should not be present. Many to one is not present. That means for each element in set X is mapped to a distinct element in set Y. So I have an example here. This surjective. Okay, you can check this function. Yeah, this one. This is an injective function or not?
yes, sir. Yes, sir.
Yes, sir.
This is
Yes,
injective.
Why is that injective?
Because there is a
Because
unique
Every input has a
one,
at least one.
every input has a unique
output.
output.
Yes.
Correct. Is this injective
No,
function?
no, sir.
No,
No,
sir, no.
Why this is not an injective function?
Because for
one
C and
output
D
has
we
a
have the
two
same
input
value.
actually.
We have the same output.
Same value.
Because for
each
C
element
and D,
of
I
given the
told
same
you
output.
many
there
to
is
one
not
is
a
not
distinct
possible.
color.
It's not even a
If many to one
function.
is not possible, then it's a not injective. Okay, this is clear to everyone. Injective function is clear to everyone.
Yes, sir.
Yes.
Now come to the surjective function. For surjective, it's like so then I have to just discuss the range, domain, and
Range is equal to codomain, then it is.
okay. So first I just have discussed the
So please discuss about domain, codomain, and range.
So okay, what is domain?
Set A
Basically,
elements,
this set
all
of
So the values that x can take.
value set of all values of that x can take. Hey, what is happening?
That actually, yeah.
Correct?
Yeah.
The domain is set of all values that where x is that x can take.
So can you give some examples?
So y equals to root x. What can be the value of x here?
All positive
numbers equal to 0.
0
But
to
can you
infinity.
take x equals to minus 5?
no, sir.
No, sir.
No, right? What should be in the root if you are taking a function? If you are taking any value, so what can be the value of x? X should be greater than equals to
All natural numbers, sir.
No,
Zero.
positive real
zero.
number.
Which of the following is correct?
The
Sir,
first
one.
First
First
one.
one, sir.
First one. Upper one, sir.
First one,
Upper one.
correct, sir.
Because x can take 0 also. At 0, what will be the value of y? 0, right? So is
0.
this clear? So
Yes,
domain is those values
Yes.
of x that can be like basically all those values that x can take.
Sir, I have a
Correct?
doubt actually. Why x cannot take minus 5?
Will be imaginary numbers.
Because this is an
That'll be a
imaginary number,
complex
right?
number.
We have not defined that. Right? Correct? Is this clear? Domain is clear to everyone.
Yes, sir.
Yes, sir.
What is the second one? The codomain. What is codomain? What is
All the
first?
values in the set B.
Possible
All the
outputs
values in the
for
set
y.
B. No, that's
Possible
range.
values of y.
Possible values for y is
All the
codomain. So
possible
the
Correct.
actual
All
values are
all range. Possible values of
All Y.
Set of all possible values. But range is what? Range is the exact value that you are getting.
actual value. Yeah.
Okay. So set of all possible, or you can say whatever she was saying about the set B. Okay. If you have making some from A to B, So you can directly say set B is a codomain. That means all the possible value that you can get. Okay, some values you will not be, it can be possible that some value you will not be getting. Okay, and range is basically the exact value that you are getting. Let's, for example, if you have y equals to x plus 1, there can be a possibility that a can be all the natural number and b can be all natural number, because see, for domain, x will take all the natural number. Okay, it can take anything, but I'm just telling you that for this example, I'm just taking a as a natural number. So b also, I have a set b that means like b also will be taking natural number. Okay, but what is the range for this case? For range, if I'm taking x as 1 and 2, so for me, range will be what? 3 and 2 and 3, right?
Range
So
will
this is
be
the exact
real
value that
number.
I'm getting 2 and 1, 2 and 3. But the codomain can be natural number, and the domain, so you can directly say that, because you can put any values, any natural number. Is this clear to everyone? The difference between codomain and range,
Yes,
and
sir.
then domain?
Yes, sir.
So can you explain codomain and range 1 second, please?
Yeah. So codomain is basically set of all possible. So I told you, right? If I have a function like this, see, I was having this example, right? I was having this example. Okay. Tell me the domain. So domain, this is a codomain, right? And what is the range for this? So tell me the range and codomain for this function if there is a relation from A to B.
Range is 1, 2, 3, 4, and the domain is A,
Yeah.
B, C,
So
D.
range is 1, 2, 3, 4. This is the exact value that you have got. But codomain is what? 1, 2, 3, 4, 5.
1 to 5.
The possible values that this function
Yes,
can get.
sir.
Correct? Is this clear to you now?
Yes, sir.
Yes, sir.
Yeah. So mostly
Yes,
codomain will be given in the question, I guess. Codomain nobody will ask you to calculate. Yeah, domain will be asked.
Sir, I have a
See,
query. Actually, I
No,
don't
sir,
calculate
that
know how
domain.
to
concept
find
is
domain.
required, sir, for understanding, because we have questions regarding from functions also.
They
Correct.
might
See.
give a function and to find the codomain.
Yes, sir.
Okay, see, mostly they'll ask you to calculate domain. How will you calculate that? You just have to, for any given function, you have to just define that function. Define that function means you just have to take all those values of x where this function is defined. If you are taking log x, what should be the value of x? Tell me. Can log take negative values?
No, sir.
Can log take 0?
No, sir.
So for
No,
log
sir.
function, log x, I don't know whether how many of you are knowing about the log function, but if somebody is knowing, x can't take. So for what should be the domain for this function x? What should be the domain for this x?
I know, sir.
So x, tell me, is this
Natural
one correct
numbers.
or this one correct? First or second?
A
0 to infinity, the second one.
Second one, because it can't take 0 also.
Second
Right?
one, sir.
So the function is something like this, okay? So for 0, it will tend to, like, it's not defined at all. So this is what I told you. For domain, to calculate domain, just define the function. Like, this function should be defined. That's it. Nothing else. Okay?
Sir, could
Is this
you refer some
clear?
question on domain, how to find domain in some particular equation?
Yeah, I'll just let you know. Okay, so I have a function y equals to
Sir, refer question on activity 11 actually.
1 upon x minus 3. What should be the domain for this function?
X should be greater than or
R
greater than
minus
X.
3.
Sir, x should be
R
greater
minus
than
3.
Real number minus 3.
Any number it can take minus 3. Correct?
Yes, sir.
Correct or not?
Except 3.
Yes, sir. Yes.
Yeah, so we'll discuss some problem from the QP also. Just let me finish this surjective, okay? Surjective and then bijective, okay, that is clear. But surjective. What is this surjective function?
If
Like every codomain is equal to range, or every set of
If range
B
is
should
equal
have a
to
pre-image
codomain, then it is
in
on
set
to.
A.
Okay, so basically for every B, so B was what? Where you are making the relation. So you're making relation from A to B. So in the every B, every element B has at least one matching A. Correct? Correct or not?
an example
Yes,
which satisfies surjective function.
Yes, sir.
So this example, is this a surjective?
Yes, sir.
Yes,
Or not?
Yes, sir.
Sir,
Yes.
it's not a
Any
function.
confusion this? Any confusion in this?
No, sir, it is surjective. No, sir, it's surjective.
It's surjective, right? This one?
No.
No, sir, it's
No, it
not.
is not.
Because
No,
Because
for the
sir.
5 is
five,
packet.
it
But
is
for
symmetric.
5,
It's injective.
what did I say? This is a condition on B. For B, for every element should be connected to some element from A, right?
Yeah.
Here 5 is not connected, so it's not surjective. Is this injective?
Yes, sir.
Yes,
Yes,
sir.
yes, sir.
Correct? Yeah. Similarly, okay, tell me whether it's a bijective function or not.
It is
Yes, sir.
bijective,
It's a
sir.
bijective.
Yes,
It's a bijective.
For
Yes, sir,
bijective,
it's a
you have to
Yes,
check
sir.
Yeah, it's a
Yes, sir,
bijective, sir,
bijective.
because the element is equals in both sides.
And every element of B has image in set A.
And one more thing, if you have to check injective function now, if you have been given the graph, okay, tell me this whether this function is injective or not.
No, sir.
Yes.
How do you check that? How did you check that?
it is injective.
It's
Yes,
injective,
sir.
sir. It is injective.
It's
Horizontal line test.
It is
Horizontal line
Injective,
test.
sir.
modulus only.
See, injective, what did I say? For injective,
vertical line.
Horizontal line test.
Only one.
horizontal line. Horizontal line. For
Yes,
vertical
sir.
line is for function. Okay. And if you're drawing a horizontal line, if this is crossing two values, then it's not injective. What did I say? If you're putting, this is a function for sure, because if you're drawing a vertical line, it is crossing 1 point. But if you're drawing a horizontal line, it is crossing 2 points. That means it's a function, but not injective. What was the condition for the injection? Injective function.
X1
It should be only one.
Codomain
One
equals
input has a one
It should,
output.
Element of
it
set
should
X
post
Main
one point, I
map to
think, in
distinct
the graph.
element in set Y. Right? One to many is not possible. Many to one is not possible. Right? So this should be a function, but one to many to one is not possible. Correct?
Excuse me, sir.
Okay. So you can check it, right? If you have a graph, you can take directly, right? For function, just drop a vertical line. For injection, like injective function, you project what? Vertical line. Sorry, horizontal line.
Horizontal
Okay,
line.
you can check it, right? Any confusion in this?
And sir, if the horizontal line cuts only two cuts at the 2 points, it's not injective now.
Yeah, if it is cutting at 2 points, it's not injective.
Excuse me, sir.
Yeah.
Sir, please check practice assignment question 11 to make understand domain and range more clearly.
Okay. Okay. Let's start discussing some problem from the practice assignment. Okay. So whatever the question you have, you can just ask me from now on. I will solve those problems. Okay. So I'll just open the portal once.
So you are solving by graphical method now, like for the injective and all these things.
Not always. We'll just check it with. We'll see.
Sir,
Depend on
but
the question.
You can choose any of the method, not only one.
So this plot and all, if the graph is given, you can directly say that. But if the graph is not given, then you have to check for each x1, right? You are getting a different value. So basically, for if x1 is not equal to x2, you are getting some different values, right? This is what we are checking for injection.
Yes.
If x1 is not equal to x2, we will be getting some y1 and y2, and that y1 and y2 is different. Correct?
Yes, sir.
If x1 is not equal to x2, implies fx1 should not be equal to fx2. This is what you should be checking for injective function.
So just to confirm, to verify using a graphical method, we need to draw horizontal line to check injective and need to draw a vertical line to check function. Is it,
Correct,
sir?
correct.
Okay, sir. Thank you.
Sir, I have a doubt, sir. Can you just please, sir, explain one more time surjective?
Okay, I'll just explain you. See, surjective is basically codomain is equals to range. That means whatever the values, whatever the numbers, elements are there in your codomain, okay, that should be attached to some element of A. There should be a mapping for sure on each of the element of B. That means for the B was codomain, right, for you?
B
Correct?
should not be empty.
Yeah, B should each and
So
every
like
element
y
should be
equals
attached
to
to
x square.
Yeah, which question you are asking? The practice assignment, which one is the question that we should be? So one with one
Sir,
question
question
I
number
guess.
11.
Okay, this is like pretty simple, right? It's not that difficult. Okay, I'll just open it. It's not the question the graded, right? This is the practice one you're asking.
Sir, your screen is still
Sir, I have also sent you an image of a question.
Sir,
Yeah. What is your deadline for week 1? The graded one?
Wednesday.
October 4th.
4th October.
4th of October.
Okay. Before that, you'll be having one more session, I guess. So do you have
Sir, on
this
Tuesday we
this
have
session
one
is
solve
happening
with the session, sir. What we'll do in that session?
Yeah, in that session we'll just solve the problem. So that is for just for the problem solve.
What problems, sir? Graded assignment problems or practice problems?
Similar problem as graded assignment and then some different problems. Not the exact one. Maybe some values will be changed, some concept, but most of the
There will
concepts
be
will
PYQ question.
PYQ question, if you need it, like you can just mail me, I can send it, but you'll get it, I guess, in the portal. I don't know when, but you'll be getting that. But if you need it, I can send you.
No, sir. In that meeting, solve with us.
Yes,
All the
solve with us,
questions
you'll
are
get some
PYQ.
problem. Yeah, you'll be
So
getting
also
some.
please send us that questions PYQ.
In the solve with us, okay, I'll just ask the team to upload the on the portal itself. Okay, I can't send it
Yes,
to each
sir.
and every people. I'll
Yes,
just
sir.
ask.
Yes, sir.
Okay,
Can
so
you
I'll
please
just.
share the screen of yours? The question, activity question.
Sir, is there any graphical method to find the subjective and bijective data?
For subjective, you can't find it with the graph, but on injective and this injective, you will be able to.
Okay.
Sir, activity question
I'll just
1.11.
discuss the practice one first and then I'll discuss. So, are you able to see my screen?
No. Yes. No.
Okay.
Hello, sir.
Yeah.
Sir, why TA sessions are not scheduled and
Yeah, it will be
calendar?
scheduled from the first week of October because I guess TH didn't reach to the Chennai till now. So I guess it will happen
Okay,
from the
sir.
first week. Okay. It will be happening.
Okay,
So tomorrow is Monday, so we'll get TX classes from tomorrow.
I need to check it, but I'm not really sure about that. But most
Hello,
probably
sir.
getting, but I am not sure. I'll just ask the team to
Okay.
fix the meeting. Okay.
Okay,
Sir.
sir.
Because
Okay.
they mostly they'll discuss all the problems like whatever you have from the activity practice. But okay.
Sir.
Okay, sir. Okay. Thank you,
That
sir.
you have. Okay.
Sir,
Yeah.
I got 99 marks in stats 1 in my term. Can I become the TA?
Not now, but because you didn't cover at least one term also, you didn't finish one term, right? Did you finish one term?
Yes, sir. I finished 1 term. I'm in the second
I
term.
guess, but now you can't be because like it's already done, right? Already people has been selected.
Completed the foundation level.
Thank you.
Yeah, so that process has been already completed. So
what is
Yes,
TA?
completed the foundational level, then mail through.
even without completing, but if you didn't get the mail for applying that, that means you're not eligible to apply. Okay, this was the question, right? Okay, you have to calculate what? Domain. How will you calculate the domain? What? Okay, so what did I say? To calculate the domain, what should be the condition? The condition should be that function should be satisfied, like function should exist. Okay, if I'm taking some random values of x where the function is not satisfied, that should not come under this domain. Okay. So what can we, so just check it. So we know that for any function like this the denominator part can't be 0. This you know, right? If this is 0, that means what this, whether this function will exist or not. If this part becomes 0.
This
No,
function will not exist.
No,
No,
right? So what are the values
Undefined,
that should
sir.
not be there in the domain? See, what are the values that should not be there in the domain according to this denominator? What are the values?
Plus 3 and
What
minus 3.
did I say? This should not be equal to 0. That means x square minus 9 should not be equals to 0. 0, right?
3 and minus 3
What are the
not-
values?
I think 3, yeah.
X should not be equals to 3.
3 are excluded.
Plus or
yeah.
minus 3.
Not equals to
Or
3.
minus
That means
3,
what? R minus 3, comma minus 3. Now you have to check for the numerator also. What did I say when I took this function? What did I say for this function? What was the condition? X should be greater than equals to 0. So what will be the condition for this case? X plus 2 greater than equals to
0.
0. What should be the condition? X minus 2, right? So what should be the domain now? So you have to merge all these things. Right? Take the union. Please mute yourself. So what should be the final value? Value of x. X should be greater than equals to minus 2, but this 3 minus 3 and minus 3. Correct?
Yes, sir.
Yeah. That means like
Sir, is
just
this
that
function
3 only,
injective
because
or
minus
surjective?
3 will not come because we are already taking x is greater than minus 2, right? Is this clear to everyone?
Yeah, sure. Yes, sir. Sir, is this function injective or surjective?
For that, okay. How will you check that?
So can you just explain the last part, sir? The 2 part, x plus 2.
See, what did I say for the numerator? What did I say? This x plus, if let's for example x plus 2 equals to minus 10. Is this satisfied? Root 10, root minus 10 is satisfied?
No, no, sir. It is a
No,
complex number.
No, right? So what should be the value? This x plus 2 should be greater than equals to what?
0.
Yeah.
0, sir.
Correct. So then from there you can get x equals greater than equals to minus 3. Can you do it for this case? Y equals to 3 minus x. Tell me the values for which to calculate the domain for this function.
Sir, x should be greater
domain for this function. Can you calculate this domain for this function? Just let me know.
Minus 3,
X
sir.
minus 3, yeah. Greater than or equal to minus 3.
Sir,
Yes,
x
sir.
should be greater than equals to minus 3, sir.
Should be greater than equals to 0, and then you can calculate. Okay, I'm just giving one more question. Just calculate this. Okay, have you solved the practice assignment, each and every question?
No, sir.
No, sir.
Sir, you didn't tell us, is it a surjective or injective?
How
For
to
which-
find the range?
Sir,
as well,
for
sir?
the last question, this 3 root x minus 3, what is answer?
Smaller than equal to.
Root.
X is
smaller
less than equal to 3.
Yeah.
Okay.
Okay. See, first of all, you will not be asked to calculate whether this function is injective and surjective for some random functions. Okay. You will be given some functions where you'll be able to find this. If you have a function like this, x plus 2 minus x minus 3 and x plus 3. Will you be able to plot the graph directly? It will be a difficult task to do that.
But sir, we can like equate it to another function for x.
You can equate
equal
it to
x2.
like that. You can put it something like this: x1 plus 2, and then x1 minus 3, and then x1 plus 3 equals to some x2 values, and then check whether you are getting x1 equals to x2 or not. This is one method to get the injective. If you are able to get this x1 equals to x2, then you can say that. Right? This is the basic method that you go and approach to check for the injective. How will you do for the surjective? Because for this function, codomain is given, or you didn't have codomain, right? For any function, I just wrote it fx equals to this one. Did I say anything about the domain and codomain? Domain you can calculate. Can you calculate codomain? You can't do it, right?
No.
For this function. Correct? So if you have been asked for any particular function, then everything will be given in everything, so that you will be able to calculate that. Okay? Is it clear to everyone?
Yes, sir.
Yeah. Now tell me the method, like wherever you have a doubt, activity question, quickly. I have some. We'll just discuss 15 minutes. The activity.
Sir,
I have a
activity
doubt in
1.10.
Okay, so we'll just go to 10.
1.9 question.
Okay, you don't have anything from 1.1. I just skip it, right?
no, no,
1.2,
no,
3, 4,
no.
5. So okay, so 10.10, 1.10 directly. You don't have anything.
1.10.
Sir,
So
1.8. I have a,
number 2, 3.
sir, I have a
Sir,
doubt in 1.8.
1.9, sir.
Okay, 1.8.
Question number 5.
What is this question number 5? Okay, this is not that difficult, right? If you have B, you have been given a function like sets you have been given with the sets of boys and girls respectively. Ramu is brother. So you have to just check it, right? So whenever you are checking that, if Ramu is a brother of Neha, you just check it. If Neha is somewhere brother with someone, then Ramu and Neha will become brother and sister. It's not that difficult to solve this, I guess.
So I also doubt.
Sir, I have
9.
solved it, but the last one is coming. The answer is last one.
What is the whole answer?
That is correct.
See which one you are missing then.
So,
Sir, I
sir,
have a
there is
doubt in
B
activity.
into G is given. So
B into G is
that
given, right?
paradigm-
Which
Yes.
one you are not getting? I'll tell you how will you get that.
Sir, let me.
Sir, I have a doubt in 1.9 actually.
Okay, we'll just discuss this and then we'll discuss the other way.
Sir, my doubt in
sir,
this question is that here they have given in question that A is brother of B, but none of there is mentioned that Anil is brother of any other girl like Neha or something. But here the answer is Anil is.
Yes, sir. Actually, and sir, the first one, in the last part,
My
Anil
answer
comma
was
Kirti.
also option 1, but correct answer said that it's answer 4.
Okay.
That's
Yes,
well.
sir. Initially, I was also getting confused. It was not mentioned, so we have to consider it like they are brother or sisters.
Which
And for
one?
all,
Which one? Tell me which one.
Actually,
Sir,
everyone
Question
is
number 5 they are
confused
talking
with
about.
last option.
The correct answer is last one, but according to question, I am getting option 1.
Yes, sir. That's the problem. Sir, actually, Anil and Kirti, it is mentioned in the last option, the first pair, the first ordered pair. But from the question, there's no link between Anil and Kirti.
Anil and Kirti. Anil and Kirti, there is a relation,
It's
right? Anil is a
mentioned,
brother of Kirti.
Oh,
No,
sorry, sir.
no,
Anil,
sir. Wait.
Kirti,
Let me tell you, sir.
Then Anil and sir Neha. Actually, Anil and Neha.
yes, sir, Anil and Neha, sir.
In question, it is obviously
See,
stated that
Suraj is
Suraj.
the brother of Neha, right? Suraj is what?
it's
Brother
logical
of?
reasoning.
Yeah, it's a logical reasoning. If Suraj is brother of Neha, NK, right? And already Neha is brother of Ramu, so you can directly say that Suraj and Ramu is also related, correct?
So we have to
Okay, sir.
assume that they are all brothers.
Yeah, correct.
Okay, sir. Okay, sir. Got it.
Yeah, directly it's not written. Okay, so you can check for the other. That's what I'm saying. If Ram is a brother of Neha and Neha is a sister or brother of anyone else, then you can directly say that. You can just think of that way also. Okay, just draw some straight line, something. Okay, this is how you solve the reasoning. Okay.
If I understand, sir, I think this is a transitive relation, right? If A is related to B and B is related to C, obviously A is related to C.
Correct. It's a
So, sir, we
transitive.
have to assume it by ourselves, like this is the condition.
This is a transitive relation example, I believe.
A is a brother of B and B is brother of C. Like you can directly say A and C is also brother, right?
Yes,
It's not
sir. Yeah, I also have a doubt, sir, in activity 1.11.
1.11. Okay, so I asked you, right?
So I also have a doubt in activity
Sorry, my
1.8
network
question 3.
connection was, I just, like, my network was shut.
Which question?
So 1.11, I have doubt in question number 7th and 8th. I'm not getting this.
1.1 now. Which one you
No,
told
sir,
me?
1.11, 1.11.
Okay, 1.11.
So can you please take my doubt?
Yeah.
So my doubt in graded assignment question number 6. Only
Graded,
describe the question.
Okay, but if I'll open it, the answer will also open. So I can't open that. I need to stop the screen sharing, then only. Okay. Okay, let me just take this out and then I'll go to that graded. Which question you are asking?
The question number the graph one, question number 7th and 8th.
That is also my problem too. I don't understand that.
Okay, graded
graph.
7. What is the domain and range of the function? So what is the domain? Just tell me.
The set A element.
Domain is all
Domain
the
that you can,
possible
value of
outcomes.
x that is
-4 to
fixed.
9.
So from -4 to 9, right? What is the range?
1 to 9.
0 to
1 to 9.
1 to
1
9,
to
right?
9.
What are the values that y will get? Range is what? The value of y. So you can write it, right? What's the issue in this?
Sir, I didn't get it, sir. Sir, please, sir, I didn't
I
get it.
didn't understand you.
Okay,
So please,
you just reply
sir,
me.
sir,
You
only
just
you
reply
can,
me.
sir, only you speak, sir, while others don't speak,
Okay,
please.
okay. So please, everyone, please be muted. So I just saying, for the domain is what the values of x that a function can take. For this
Yes, sir.
function, what are the values that this function is taking? What are the value of x? Just see that. It starts with -4. It is taking all the values from -4 to 9, right?
Yes, sir.
So domain is -4 to 9.
Yes, sir.
What are the values of range? Range is what? What are the values that function is getting? So if function is y equals to fx, what are the value that y is getting after putting x? So the values for some x equals to, so you just take it. So it is varying from, what is the value it is varying from? 1 to 9, right?
Yes, sir.
Take any other values of y from apart from 1 to 9? No, right?
No, sir.
So that means the range is 1 to 9. This is
Yeah,
what is
and so that in bracket mx and ny, m is actually denoting that m is that domain x values, no? Okay, sir, I was getting confused. And sir,
then,
and same, sorry.
Sir, then how come the answer is not -4, comma 9 in question number 7?
What is
Minus-
the given answer then?
It's asked about m and n, not mx.
M and n is asking, right? The first one of this m and this one is asking. So I told you, right? It's from -4 to 9, and this is from 1 to, sorry, -4 to 9, and this is from 1 to 9. So -4 and 1 should be the answer. Yeah, this is correct, right? What is the given answer? Yeah, -4 to 1.
Sir, I have a
Yeah.
doubt regarding calculating
So
maximum.
Yeah. Go ahead. Quick. Please
Sir,
ask.
so here m and n will be like all the values that it can take, no? Like the smallest to the smallest m.
No. See, mx is the value that is, see, just write it here, na? M. What is m here?
M
What
is
is
the
m?
like -4 to 9.
M is what? -4, right?
Yeah.
X is what?
9.
9.
X is
Similarly, n is what? 1. Y is what? 9.
9.
Correct? Just put the value now. It's asking for mn, not mx. It's asking mn. Just put it. What is the value m it was taking? -4. What is the value it was taking n here? 1. This is done, right? Similarly, it's asking for xy. Then just put
Sir,
the
I have a
value.
doubt regarding
9,
Is
So
it
I have
clear
a doubt
now?
in one.
Sir, I have a doubt of first question of same assignment.
Can you please
Oh,
explain
first
maximum
question.
minimum with an example?
Yeah, this is simple, right? You just have to calculate domain. So I told you, right? So denominator can't be 0. To exclude the denominator where it is taking 0, what can be the value of x?
2.
2, right? If we are putting x equals to 2 here, it will be, the denominator part will be 0, right? That we don't have to take. So it will take r -2, right? It can take
Sir,
all
but
the
for
values,
the
only 2 will be
numerator-
excluded, right?
Sir, for numerator here in the square root is
Sir,
not
seriously,
present.
I'm not able to hear you, Kartikan or
Sir,
in
explain
this
again. Explain again.
numerator there is no square
denominator
root.
can't be 0 for a function. For a function, 1 upon 0 is not defined. So this function, it can take all the values, but it should not be taking any values where denominator is 0. So when is the denominator 0? 4x minus 8 equals to 0. That means x should not be equals to 2.
Yes.
Correct? So you have to just exclude the 2 from R.
Okay, got it.
Okay.
Sir, I got a question for this.
And some
that,
question number second, sir.
Previously, you explained with the square root on numerator. Here, the square root is not available for display. So, how, sir?
Okay, this will be the last question that I'm taking. You can ask me.
Sir, I understood the question number second.
5, sir.
The question number second.
Question number second is done. Oh, okay, I have.
Please take question number 5.
Okay. So the product of minimum value. What can be the minimum value of this function?
So I understood the question. So I'm saying that for the maximum value of the function, it will be like if this is the equation in the question, then the maximum value will always be the 11 number, like always that integer.
What? I didn't get you.
So I'm saying that for the maximum value of the function, we will always put the something that gives the number itself, like here.
If you have to calculate maximum value, some 11, some constant minus something, when can you get the maximum value? Tell me.
So I was earlier putting here 3.
No, I'm just asking you if you have to get some maximum value and your
Minimum,
function is given like
minimum.
constant minus x, what can be the value of x? It is as minimum as possible, right?
Yes,
To get
sir.
the
Yes,
maximum.
sir.
So what
Yes,
should we
sir.
put here? So what should be the maximum value? Tell me.
11 minus x plus 8 now. So I was earlier
What should be
put
the value of x such that this function will be maximum?
So
I told you, right? If you have a function, c function equals to c minus x. Okay. And if you have to maximize this, what can be the value of x? And this is something mod. The value.
0.
0,
right?
yes, sir. Yes, sir.
If you're
Yes,
putting
sir.
0 here, you'll get c as a maximum number, right?
Yes, sir.
If you're putting anything else, it will be reducing this value. So the same thing is asking here, right?
Okay,
11
sir.
minus some constant, right? And this is in the mod, that means you should be just putting it as such that it will be 0. 11 into minus 8, because this is you are asking for minimum value. So here also x
Yes,
will be
sir.
0, right? 11 into 8 minus 8 is minus 88.
So we have
What
to
was-
make the mod value 0. Yes, sir.
See, and this also there is no formula for that. You just have to go question by
Think.
question.
Yes,
Yeah.
sir.
Sir,
Thank you so
can I
much, sir.
ask one question?
Yeah.
In 1.6, question number 2, I don't understand what's the difference between or and here.
Question number 6, sir.
Question 1.6, question number 2. Why I did mark my fourth option, which has and answer, but
Where?
Question number 2.
Okay. So you have to ask which of the following set comprehension defines a real number in the interval minus 2 to 0 and then 4 to 8.
I marked the fourth option, but it says it should be or in between there, not and. Why?
Because 4 is not included, no? You should not be including 4, right? You can't include 4, right? 4 is like open bracket.
Okay.
So open bracket means 4 is not included. After 4.00001 is included, but 4 is not included. Okay?
Okay.
Did you get the? Okay.
Sir, I have doubt in activity 1.10, question number 7, sir.
Okay, but I'll not be able to not be able
So,
to take much doubt.
sir,
So
if we
already
had just closed the here bracket, then we would have written and, right?
Huh.
No, sir, because of union, it will be remain or, right?
No, union, if you are taking union also, that means what? If this is a closed bracket, that means it will include 4, right?
Yeah, but that will only differ from that will only change the statement r greater than equal to 4.
Yeah,
Not
this is
the
what
or
I'm
and
saying.
and statement.
No, nothing. No, not or and and. No, okay, you are asking or and and. I thought
Yes,
you are
yes,
asking
yes.
about the greater than equals to.
No, sir. I am just asking or and parts.
No, it will be or only. It will not be, because it's a union, right? Union means that and that other one also. Intersection, then only you can take and. Intersection is why intersection. It should satisfy both the condition. Union is what? It can satisfy first one condition also, second also. Can first or second.
Okay,
intersection is it should satisfy both the condition. There's no other issue, right?
Okay, sir. Thank you.
So just a small doubt.
Yeah,
What
activity
is the formula to
1.10.
calculate subset, like power subset, just the small doubt.
How do you calculate
2
power?
power
2
n.
raised to n. 2 raised to n.
It's already
2 power
written,
n.
right?
I think it was 2 raised to the power n.
Or
Yeah.
n minus 1, like.
No,
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 2
only
power
n.
mn.
No, there is only 2 raised to n.
n.
That was written in notes, I think.
What?
It was mentioned in our class, 2 raised to power n.
So what are the formulas written? It's correct. So is there any doubt? I guess no, right? So
Sir, please share your email ID again.
Yeah, I just wrote it right. You can just send me the doubt, whatever is left. If
Can
I'll
you
be-
send it again?
Activity
Just
1.10,
writing my
question
mail
number
ID.
7, sir.
Okay, so we have more sessions, so don't worry about that. Okay.
So, but we don't have a chance to ask question. Only every person, each person is asking every question. Means you have not giving chance to everyone, right? Better they ask them to raise
That's why I'm
hands
sharing
and
the mail
order.
ID, right? You can just write it to the mail ID, okay? And we have sessions from tomorrow onwards. We'll be having more sessions, so
The
don't worry
deadline
about
is deadline is nearing, sir. We could not wait for the answers now because most of the mail also will be received. You
Sir,
could
for
not be
next
answered for all the
session,
questions.
No,
for
most
next
of the people
session, please
don't
go with
like
hand
whoever
raising,
is sincere.
sir.
I mostly hardly get any. I'm just sharing this mail ID for long, but I hardly get any questions. Like maybe
Sir,
in
sir,
each
next,
term I'll be getting some 10 questions. That's it.
sir, next session will be of solving together, right? We will solve.
Yeah, solve with us. Yeah. And there will be one more
And,
session to just discuss the activity question and practice assignment. Okay.
So will
Before
it
this.
contain similar question as graded?
Yeah, it will
assignment
contain
and-
similar question as graded. Yeah.
Okay, thank you, sir. Thank you very much.
Sir,
Okay, I'll update the calendar also. I'll update that, so don't worry.
will this session be recorded also?
Yeah, it's
And
already
Yes,
recorded.
yes, recorded.
Live, right?
You can
It's
find
live on
that in
YouTube,
calendar.
Yeah. Okay, so I'll be taking. If you have
Sir?
any other doubt, you can just mail me, or we'll be having more
Sir?
sessions. Okay, don't worry about that.
Sir?
Yeah.
Sir, about the qualifier exam, is it all MCQ questions?
Not all, like it will all be like MCQ, MSQ, and then NAT. NAT, you understand, right?
Like
So you have to
what is
just
it?
put the values from 1 to infinite, like any value.
Okay, sir. Only those 3 questions?
Those 3 type of questions. Yeah. MSQ, multiple select. MCQ will not be any having any writing type of questions.
So
even in other subjects, sir?
In all the like sub courses, there are where you have to write it, but not in first year. At least it will start from
So
third.
can we
Like
use
Every
calculator?
subject,
For
sir.
qualifier
Sir,
exam?
I had a question.
Every
Qualifier, you don't
subject,
have any,
sir.
like you just have MCQ, MSQ, and then NAT.
So
That's it.
can we use
Yes, sir.
calculator
Thank you, sir.
on exam?
Yeah.
Can we use
Sir?
calculator on exam?
I can't hear you. Whoever was saying case of.
Can we use
Yes, the
calculator?
calculator.
No,
Yes, it is
calculator, no,
given.
everything will be there. Everything will be there in the wherever you'll be solving. The TCA center, no? All the PCs
Yes,
will be
sir.
having the calculator. So don't worry about the calculator. You should be knowing how to use that. That is good enough.
Thank you, sir.
Thank you.
So I had a question, not regarding to the subject, but I'm not able to log into the discourse thing, sir.
Discourse will not be after qualifier and all.
So
will
I
be
have qualified. I'm in my 3rd term this time, so I am not able to log into. I actually did not clear
Okay, then
maths
why
1
are
last
you
time.
not
That's why
writing to the team? Like
I did
Right.
write to this.
Write
okay,
to
what's
support
your
team and call.
what's your okay? You just mail me, okay, regarding this. I'll just forward
sir.
it to the team so that
Mail and sir, call
clarify this.
available for.
Please
Mail,
mail me,
please, sir.
okay? Whoever was asking the doubt, please mail me regarding that, okay? I'll
Okay,
just
sir.
forward that.
Okay, sir.
Sir, and one more thing, will we be able to use pen and paper for, like, if you want to draw a graph or something in the exam?
No, they don't give.
Yes, they will give you the
Yeah,
paper
they
and
will give
have
you the
to
sheet
bring you
and pen.
the pen for
Okay,
the
those
exam,
things
right?
they'll be giving you for rough pen.
Okay, sir. Thank you, sir.
Is this the meeting is over?
What?
Thank you, sir. Bye, sir.
Session is closed, sir.
Yeah, session is done. We'll meet in the next session.
Thank you, sir.
Okay, sir. Thank you.
Thank you, sir.
Bye.
Good night, sir.
Thank you, sir.
Good night.
Thank you, sir. Good night. was very
Good
useful.
night, sir.
Good night, sir. Bye, sir.
Good night, sir. Thank you, sir.
Good night, sir. Thank you.
Good night, sir. Thank you, sir. Bye, sir.
Yeah, good night. Good night, everyone. Thanks for
Good
joining.
night, sir. Bye.
Thank you, sir. Bye, sir. Sir, what's your email ID?
I just wrote it right in the chat box there.
So can you please note again, sir? Thank you, sir.
Yeah, Mahesh. Yeah, please close the session. Okay, okay. Thanks. Okay, okay. Then bye, everyone. Have a good night, and then
Thank you, sir.
we'll meet in the
Thank
next
you.
week.
Bye-bye.
Bye, sir. Thank you, sir. Bye, sir.
Bye. Bye.